I have never written shader. One time when I was like a little kiddo in college, just learning about like the universe, I decided I'm going to write a shader. And I got a book and I started looking at it. And one of the examples in the book has a light swinging everywhere, creating shadows and penumbras and umbras and all that stuff. And I looked at it and then I said, I don't get this at all. And then I never looked at it again. So that means it's time for me to actually learn about that. That was me in 2006. That was me in 2009. So it's like not even right when HLSL was just coming out. We're going to start with a little bit of the book of shaders. We'll start kind of just poking our little eyeballs at it. And this is a gentle, I need a gentle, bro. I need this gentle. I need a gentle. I need it as gentle gets because I'm going to absolutely die. All right, so here you go. Okay, let's get started. So I don't even know what a shader is. Let's look at a shader. If you've already have experience making drawings with computers, you know that the process you draw a circle, then a rectangle, a line, some triangles until you compose an image you want. Wait, that's how you guys do it? That process is very similar to writing a letter or a book by hand. It is a set of instructions that do one task after another. Okay. Shaders are also a set of instructions, but the instructions are executed all at once for every single pixel on the screen. See, okay, so that's what I thought. Okay, that's what I thought. So that must be how like Gaussian blurs work, right? A Gaussian blur, one would assume, with my extensive shader knowledge, that you take a pixel and then you take the surrounding pixels and you take their values, which I don't even know how you get these values, and maybe even these ones, I'm not even sure, and you like do some sort of averaging into here, and then another thing I don't get is then you have like your pixels that are your original image, and then does this generate a second like thing that then gets applied? Is it kind of like how you do physics, how you have your next positions and then you see which one can apply? Not exactly though, not all at once for all pixels. Yeah, see, I don't quite get all of these kind of things. Or yeah, appreciate that. So again, I have like extremely small, my understanding is as small as they get, right? That means code you write has to behave depending on the position of the pixel on the screen. Okay, like a type press, your program will work as a function that receives a position and returns a color. When it's compiled, it will run extraordinarily fast. I don't know. Have you seen my code? I don't know. Okay, I don't know. There's a lot of assumptions. There's a lot of assumptions being made here. By the way, that is so cool. See, look at that blur. See, I assume that blur is done by averaging pixels around it more and more, like maybe even further and further averaging goes on. Maybe only like 10% averaging works here as it gets away from the center, but I don't understand how this works. Like, how does it know where the center is? I don't know. How do you pass values to a shader? I effing don't even know. That's one type of blur. You can blur these nuts. The other type of blur, obviously, is when you lose focus on a div element. Okay? Classic blur. Like when you think of blur and I think of blur, we think of it together as losing focus, right? Blurring the lines. Imagine the CPU of your computer as a big industrial pipe. Oh, girl, I imagine it that way all the time. Thank you, Code Girl. Every task as something that passes through it. Like a factory line. Some tasks are bigger than others. Statistically speaking, that description's correct, which means that they require more time and energy to deal with. We say that we require more processing power because of the architecture of computers. The jobs are forced to run in series. Each job has to finish one at a time. Modern computers usually have a group of 4 processors that work like these pipes, completing tasks one after another to keep things running smoothly. Each pipe is known as a thread. Okay, so I assume what it means is that I think we're drawing the conclusion that every pixel effectively can run if you had enough GPU mini cores, and since GPU mini cores aren't that fast, but there's like a gajillion of them, you can run huge swaths of your screen at a time. Video games and other graphic applications require a lot more processing than other programs because their graphic content, they have to do a huge number of pixel by pixel operations. Every single pixel on the screen needs to be computed. In a 3D game, geometries and perspectives need to be calculated as well. Okay, I feel like I kind of get this. Let's go back to the metaphor of the pipes task. Each pipe on the screen represents a simple small task. Individually, each pixel isn't an issue for a CPU. But, and here's the problem, the tiny task has to be done to each pixel on the screen. That means an old 800 by 600, that's huge, by the way, that's a big number, it has 480,000 pixels, have to process per frame, which means 14.4 million calculations per second. And that's only what? That's 30 frames. That's not even talking about 144th. That's not even 144 frames here. That's a problem big enough to overload.
I still love you, Prime.
I love you too, baby. To overload a microprocessor in a modern 20. Oh, that's what, that 1440? What is that? What is this number? That's not 1440, is that? What number is this? I don't even know. I don't even know what this is. A retina display running at 60 frames per second. That calculations adds up to 311 million calculations per second. That's not 1440. It's 18p. It's 1800p. Non-standard resolution. Yeah.
Hi.
Hey, what's up, Code Girl? You doing good? I was hoping that you guys would ask me great questions, but I see that this degenerated into nothing.
Just sending this to break your flow.
Did you know that I feel like I don't think you have to have your context broken when you get interrupted for a second. I think that people allow themselves to have their context broken. When you get your context broken for just a moment, often what you do right afterwards is you do some other task. And when you do some other task, that's really what gets your whole life ruined. And that's when you actually get your context broken. I just personally find that if someone interrupts me, I just go right back to what I'm doing. And I don't feel like there's a big hiccup. Like I don't need a 15-minute, I better get warmed back up to the process. It's like, no, you don't get distracted. Don't go on Twitter. That's where you get screwed.
Can you read more?
I can.
Stop stopping.
I will. Howdy, new here. However, I'm a developer in ShaderAmp. Oh, nice. Free MIT browser extension. Oh, that's cool. But with shaders, please take a look-see. I'm not going to take a look-see right now. All right. When the parallel processing becomes a good solution, instead of having a couple big old powerful microprocessors or pipes. Right? You know what I'm talking about? Know what I'm talking about, girl?
I'm an artist. You broke my brain already.
Oh, thank you. I'm an artist too. Hey, thank you, Jared. Appreciate that. I'm an artist. You know what I'm talking about? It is smarter to have lots of tiny microprocessors running in parallel at the same time. That's what a graphics processor unit is. Okay, see, that makes sense. Look at all those. Look at all those bits going through all those little tunnels.
Welcome to Costco.
You know what I mean? Good morning. Just lost my SWE job in South Florida. Whoa. Man, I'm sorry. I have this I would say that has always been one of my big life fears, is to have all my life set up and kind of wanting to do something and, I put myself, say, into debt and all those kind of things just to have something taken away from me. Even just like this streaming whole thing that we're doing right here. Like there is a definite reality that this stream just ends someday. People don't think I'm funny. I get too old, my bones start creaking, my fossils get old. Maybe I lose my voice like I did. I lost my voice for like a month. Like just things change. Maybe the culture changes and I can't change with it. I'm no longer Zoomer funny, right? Like that could happen. Like all those are real. And so then it ends up being like, you make commitments, you make ideas, you set up your life around something and then it's taken away from you. Oh man.
Welcome to Costco.
I'm sorry, bud.
I love you.
I genuinely appreciate you being here. I hope that you can find lots of success. I think a really good way to go about this is that, especially if you get severance, take that time that someone just paid for you and go deep and learn what you really want to learn to start advertising your abilities for positions you want to be in. I think a lot of times people use severance like as a means to relax, or they take the first couple weeks off and they're just like, oh man, that was awful. But instead it feels like all I want in those situations is to find my ideal job for a moment and attempt to swing for the fence as opposed to just trying to find the exact next job right away. So just train for that position. Find the job you really want if you have that. I'm getting severance. Thank you so much for the advice. Hey, that's awesome to hear, DJ Hunter, obviously. Use it well, but just go all in on learning what you really want to learn and finding the job you really, really want. Because right now you just got given a go find a job free card for a little bit. Even if it's only a couple weeks, it's still a couple weeks. In my experience, no amount of learning translates into job opportunity. It's not been my learning. Being able to confidently talk about something is really, really good in an interview. It's no amount of learning can excuse the inability to communicate what you've learned. That's what I think. All right. Another superpower of GPUs is special math functions accelerated via hardware, so complicated math operations are resolved directly by the microchips instead of software. That means extra fast trigonometrical and matrix operations, as fast as electricity can go. That's pretty cool. What is GLSL? It stands for OpenGL Shading Language, which is a specific standard of shader programs you'll see in the following chapters. There are other types of shaders depending on hardware and operating systems. Here we'll work with OpenGL specs regulated by the Kronos Group. Understanding the history of WebGL or OpenGL can be helpful for understanding the most weird conventions. For that, I recommend this one. What is WebGL? Okay. Why are shaders famously painful? As Uncle Ben, I don't know who Uncle Ben said, who is this person, said, with great power comes great responsibility. I now know who Uncle Ben is. I should have just read the quote before saying anything. Now I look like a doofus. Hey, Grimace, thank you for the brand new Tier 1. Hey, Grimace, can I tell you something? I lack confidence in certain social situations.
I love you.
All right, in order to run in parallel, every pipe or thread has to be independent from every other thread. True. True.
You once said that errors should be understood. But you shouldn't Google or ask an LLM. Do you have any tips on how I can really understand errors if I'm not supposed to Google? I'm pretty new to programming and don't understand that much.
Okay, first off, nothing's wrong with Googling an error. I think you should Google an error. But your early errors are almost exclusively syntax errors. And those are very, very important. And so take a moment to look at the error, try to take a guess or two, then go look it up on Google, or use OpenAI or whatever you want to use to kind of solve that error. When you solve that error, then relate what was the error saying to what was the syntax issue that you were having, and go, okay, the next time I see that, I should know how to solve this. I've seen this once. I can now solve this issue. And when the next time it comes up, don't just go to OpenAI and just paste in the error. Instead, go, okay, I've seen this before. Last time it was fixing this, or that. Therefore, I got to do it again. Lots of syntax errors will literally tell you the problem. Yeah, and most modern languages will just tell you, like, hey, something's wrong in this general reason. Like, learning how to do your basic error detection is really good. And then if you get bugs, learn how to debug. Like if something isn't behaving properly, learn how to debug it. Don't just simply paste in your code, paste in the error, ChatGPT, what went wrong? Learn to close the window. If you've done enough debugging, you know exactly what that means. Closing the window simply means you have a breakpoint here. That's where the problem hasn't happened yet. You have a breakpoint here. This is where the problem has happened. How do you bring that window in until you find the problem? Just don't break the window. Facts. In order to run in parallel, oh, by the way, Cater Waiter, thank you. Every pipe or thread has to be independent from every other thread. By the way, when I say don't just simply Google errors or whatever, when it comes to TypeScript configuration errors, go ahead, ChatGPT them. I personally could care less about those. Anyways, let's see, say that threads are blind to the rest of what the threads are doing. This restriction implies that all data must flow in the same direction, so it's impossible to check the results of another thread, modify the input data, or pass the outcome of a thread into another thread. Allowing thread-to-thread communication puts the integrity of the data at risk. Yeah, and it also, it would be massively slow, right? Because you'd have to have like mutaces all over the place. Also, the GPU keeps the parallel microprocessing the pipes constantly busy. As soon as they get free, they receive new information to process. It's impossible for a thread to know what is it doing in the previous moment. It could be drawing a button from the UI of the operating system, then rendering a portion of the sky in a game, then displaying a text of an email. Each thread is not just blind, but also memoryless. Okay. This makes sense. Besides the abstraction required to code a general function that changes the result pixel by pixel depending on its position, the blind and memoryless constraints make shaders not very popular among beginning programmers. Yeah, okay, but that makes... okay, so this makes Haskell nerds very horny, right? Like, this is Haskell Nerd 101. You want your functions blind and memoryless. In other words, pure. Don't worry. In the following chapters, we'll step-by-step learn how to go from a simple to advanced shading computations. If you're reading this with modern browser, you'll appreciate playing with the interactive examples. So let's not delay any longer. Press next to go next. Let's go. Okay, this is fantastic. I'm very excited right now. I'm just absolutely pumped right now. All right, but first, I gotta go pee. I gotta go peep. Sorry. Did someone link Jonathan Blow's tweet about shaders the other day? I don't know anything about, like, again, I have no idea. Do functional programmers just totally shit themselves when they have to write shader code? Or what's the deal? Yeah. That is so funny that we both had, like, literally an identical thought. That is so good. Yes, liked. That is so awesome. I agree. Well, it just makes perfect sense. No new ideas, I know. Turns out my super cool joke, not even funny. It's not even a funny joke. All right, hello world. Usually the hello world example is the first step to learning a new language. It is a one-line program that outputs an enthusiastic welcome message that declares opportunities ahead. In GPU land, rendering text is overly complicated. I can imagine. I have. Whew. Instead, we'll choose a bright color to welcome our enthusiasm. The fact that this is not cornflower blue actually makes me pretty upset. Now, so what I'm thinking here is instead of doing this, like it really should be cornflower blue. Cornflower blue is about right about there. Did I get pretty close to cornflower blue? Have you seen Michael Reeves' video about the... Wait, hold on. What? Have you seen Michael Reeves' video? Oh, collab between you two would have me in tears? Yeah, I've seen a lot of Michael Reeves' video. Michael Reeves is awesome. The author of the book also created a library with all the boilerplate loaded shaders into the canvas. It saves you a ton of time. Oh, GLSL canvas? Okay, cool. Yeah, Michael Reeves is awesome. What's cornflower blue? Cornflower blue apparently is like... cornflower blue is supposed to be like the color. Yeah, see, I got pretty close to it. I got pretty close to that. Wow, hey, that was pretty close. Hey, that was pretty close.
I love you.
Okay, you must admit that was pretty close. Hey, thank you. Joe, appreciate that. Cornflower blue is like the classic color that Hello World happens in game program or right in graphics programming, right? It's like first cornflower blue and then hello triangle. Yeah, that's it, right? That's as far as I understand. I thought it was magenta. Nah, magenta's weak. X and A, like X and A default color, right? Oh. I was hoping to see like, yeah, there you go. Look at the cornflower blue behind it. A lot of cornflower blue. Come on. I at least know that. I know that's a real thing. Okay, let's keep on going. I actually want to try to get a little bit further. All right, so I want to be able to set this up and actually use this web GSSL. Okay, grab that thing, install GLSL canvas, creates a canvas element in your HTML, adds the class name GLSL canvas, assign it to a shader through the URL using data fragment URL, or directly write this one. Okay. That's it. It will automatically load a WebGL context in the canvas element, compile the shader, and animate it for you. As you can see in this example, we are loading the fragment shader by setting the attribute data fragment URL. This can't be that hard to do, though. Right? Like, can it really be that? Like, it must only be, like, tens of lines of code? Famous last words. This isn't the hard part. This feels like the easy part. Watch. We'll just go to open. We'll just go to the open Jippities. Give me the code to start a canvas where I can and a basic cornflower blue coloring with a shader. Boom. Give me that thing because I want to translate that. I want to see how close this is because my guess is it's really, really close. There's the JavaScript. I don't know what binding it to a shader is. Okay, we're still learning. We're still learning things. Look, there's the WebGL canvas. Get context WebGL. If there's a, we don't have that one. We get the viewport. We do all these things. Set the viewport. Color a buffer bit. There's the, okay, so there's the shader source. GL position. I still don't know what that means. Fragment shader. There's the color, cornflower blue. Nice. Compile the shader. Oh, gosh. You got to compile a shader. Create. Okay, we got to do a GL create shader. What the hell is GL again? Okay, that's a canvas context. Okay, so you just get a canvas context. You create the shader. You set the source. You compile the shader. Get shader parameter. Compile status. If there's no compile status, then we delete the shader and it's a problem. Else we return the shader. We compile the vertex shader and the fragment shader. Create the program. Attach the shader. Link the program. Shit. Okay, maybe there was more. Maybe it's true that there's a lot. Well, then how come this was so simple? Maybe you underestimated the problem. Maybe I underestimated the problem. How come this one looks so easy? Look at that. Uniform float U time. Precision float medium P. What is a medium P, by the way? I don't know what a medium P is. That is only a fragment shader because it's in C. Medium precision. That must be like a float 32. Push and P. Yeah. Just is that all it is? Is that just a float 32? Is what a medium precision is? No. Okay. Oh, it's a 16. It's a 16. It's about 6 inches. Yeah, right. 6 inches. You think someone just has like 6 inches laying around? Yeah, right. All right. Let's just copy this code. All right. Let's copy the code. All right. So this is what we're going to do. I'm going to jump in here and I am going to go like this. I'm going to go shader.html and I created a quick directory because I'm a dummy. Instead, we're going to go like this. Shader.html. Shader.html. All right. Let's just start with it in here, almost in here. Okay, we're not that dumb. Okay, we're not, chat, we're not that dumb, right? Right, chat? Shader, jump in here, index.js. Okay, do one of these. Yeah, there we go. This is looking good. All right, this is looking good. Okay, then we're going to go grab a context by this one, go in here, single quotes to double quotes, grab one of those, jump up to this bad boy, go in here, go type, what is this thing called? HTML canvas, right? What is this thing called? HTML, oh, didn't give it the old one of those, huh? HTML canvas. Why aren't you completing? Why are you, isn't get canvas the thing? Isn't get context the thing? Why is that not working? Oh, let me just get this all in here. All right, there we go. And then I'm just gonna run canvas in here. Let's see, HTML canvas element. Yeah, see, I thought it was canvas element. Is it not a canvas element? Am I just crazy? Oh, there you go. Now it works. Oh, cool. Now it works. Yeah, cool. There we go. All right, perfect. So now we have all the things we want. All right, so this all looks good. Now we can slowly understand this. Okay, so this looks pretty good. I'm happy with what is happening here. Let's go in here. Let's find that shader. Let's go like that. Let's get rid of all this thing. Put that right there. All right, perfect. Take the script and we go source equals shader index.js, right? That's all. I think that's all you have to do. Right? There we go. And then go shader.html. All right, cornflower blue. You should definitely extract the shader code into its own file, though. We will get there. All right. So we have this. Okay, so we have this vertex shader, which I don't really quite... Okay, so I don't understand this. We have a position, so this must be... I don't know what that is. Okay, my assumption is that this goes A positions X, Y, so this is Z. Z comes out of the screen, right? Negative Z goes out of the screen, correct? And then 1 means fully... 1's W? I don't even know what 1 is. I don't even know what the hell that is. Vertex is a per vertex model. W or alpha. Yeah, see, it's the double. I don't even know what W is. Read book of shaders. We are reading the book of shaders. Okay, medium P dump. We see that one. Okay, so we have the exact same thing set up as the book of shaders now. All right. If you're reading this book in a browser, the previous code block is interactive. That means you can click and change any part of the code you want to explore. Changes will be updated immediately thanks to the GPU architecture that compiles and replaces shaders on the fly. Give it a try by changing the values on line 8. We did that already. We got pretty close to cornflower blue. I got 416-630-11, and this thing is 416, a little off here. Yeah, see, I was a little off. I was just a little off. Just a little off. Okay. Although these codes, although the lines of code don't look like a lot, we can infer substantial knowledge from them. Shader language has a single main function that returns a color at the end. This is similar to C. The final pixel color is assigned to the reserved global GL frag color. Ooh. GL frag color. Okay. Cool. Okay, vertex shader. So this changes the vertices of something. This changes the fragments of something. Okay. It doesn't return it. It just has a global value. Okay, that makes sense. The C-flavored language has a built-in variables like GL frag color, functions, and types. In this case, we've just been introduced to vec4. That stands for a 4-dimensional vector of floating point precision. Later, we'll see more types like vec3 and vec2, together with the popular float, int, and bool. Bool. If we look closely to the vec4 type, we can infer that the 4 arguments respond to the red, green, blue, and alpha channels. Okay. Yep. Also, we can see that the values are normalized, which means they go from a value of 0 to 1. Okay, this makes sense. Later, we'll learn how normalizing of values makes it easier to map the values between variables. Okay. Another important C features that we can see each example is the presence of a preprocessor macros. Macros are a part of the pre-compilation step. With them, it is possible to define global variables and do some basic conditional operation. With if-def, oh, I love if-def. If there's one thing I can say that I love about programming, it's preprocessor macros. They make your life easier. Everybody enjoys them. There is universal love for a pre-compiled piece of code that gets executed and created as text replacements. No, I'm not talking about like actual macros and metaprogramming. No. We're talking about straight up string replacements. Everybody knows those are the best form of programming. Also, if you work with them long enough, you want to commit Sudoku. All right. So, hell yeah, brother. Replace these nuts. If true equals 0, define false equals 1. Yeah, said knock, baby. Said knock, baby. Said knock. Nice to have redefined functions. Yeah. Was that a misclick? Nope, not a misclick. Hell yeah, brother. All right, float types are vital. Hold on just 1 second. Flip told me to do something, and I'm gonna do that something. Isn't that right, Flippy? Isn't that right, Flipperino? I think Flip's still around here. Or he's not. My professor hates them? Yeah, because your professor's smart. Pre-processor macros are horrible, okay? That's just that. Ben here, yeah. He was right. It's a joke. I made a joke. I made a ha-ha. I made a hee-hee and a ha-ha, okay? There's not a single person on earth that walks around like, you know what would be really great right now? I would actually like it if instead of having some sort of ability to check your syntax, I would like a program that runs first and replaces all the symbols, and then afterwards you check the syntax. And then I'd also like to make it so that it looks like a function, but it's not one. It's like, no, nobody wants that. Nobody wants that. No. We call it C++, bro. Okay, float types are vital in shaders, so the level of precision is crucial. Lower precision means faster rendering. Is that always true? I gotta understand how that's possibly true. And the reason why I say that is that when you do a float, like, at least in CPUs, when you do an add operation, say you add two 8-bit operations, it's not like it's any faster or slower than adding two 64-bit ones if you're on a 64-bit architecture, because it's still like you still have a pipeline that needs to run through. Like, it's still the same thing, right? You still have 64-bit registers that are grabbing these 8 bits and then piping it through. So I don't really understand that part. It's memory. You're dealing with millions of floats in parallel. SIMD's nuts, exactly. But that works on memory stuff. It depends on the Jeopardy architecture. Okay. You're still dimping the pipes, yeah. You can combine 232 into 164. But that's not easy to do. Anyways, thank you, Just Alex. I appreciate that. And BZ Kaz, appreciate that. Tomorrow's StarCraft stream, no. But the cost of quality. You can be picky and specify the precision of each variable that uses floating point. The second line, precision, medium, P, float. We are setting all floats to medium precision, but we can choose to set them to low precision or high precision. The last and maybe most important detail is that GLSL spec doesn't guarantee that variables will automatically will be automatically casted. What does that mean? Manufacturers have different approaches to accelerate graphics card processes, but they are forced to guarantee minimum specs. Automatic casting is not one of them. In our Hello World example, VEC 4 has a floating point precision.
Welcome to Costco.
And for that, it expects it to be assigned with floats. If you want to make a good, consistent code and not spend hours debugging white screens, get used to putting the point in your floats. This kind of code will not always work. Very, very amazing information right there. Okay. You don't want to spend hours debugging white screens? Also, it seems like shaders have to be the worst thing in the world to debug, because you only can debug it by running the thing, right? There's not like, I assume there's not like console logging. There's not like all this easy stuff. There's shader log, but most people don't know about it. Okay, there is logging. That's cool. So that could help, but that also seems like it would not help at all. There are graphics debuggers. Oh, okay. Try a unit test shader. I dare you. No, I don't think so. Now that we've described the most relevant examples, by the way, thank you, Gurns back. Gurns, appreciate the 6 months in advance tier 1. That's crazy. 6 months in advance? Dog. That's amazing. What are you doing? Now that we've described the most relevant elements of our Hello World program, it's time to click on the code block and start challenging all that we've learned. Okay, I feel a little challenged right now. You will note that on errors, the program will fail to compile, showing a white screen. There are some interesting things to try. For example, try replacing the floats with integers. Your graphic card may or may not tolerate this behavior. Try commenting out line 8 and not assigning any pixel value to the function. Try making a separate function that returns a specific color and use inside main. As a hint, here's the code for that function to return. All right, yeah, let me try. Yeah, that seems like a good idea. There we go. Red. Okay, that kind of seems fun. Hey, that kind of seems fun.
Welcome to Costco. I love you.
Well, hey, that didn't seem to do anything. What the hell's happening there? What? Wait, what? How is it getting blue though? Okay, that part I don't understand. That can't be right. It's because I don't have cache disabled. You know what I hate? I hate the fact that I can't just have cache always disabled. Okay. Nope. Argument 2 is not an object. Oh, we're getting a cache. Oh, I must be, yeah, okay, I forgot that. Oh boy. Oh, oh boy, this will definitely be painful. This is gonna emotionally hurt. Just want to let you know. Thank you, Zig. Appreciate that, and thank you, Shiro. Okay, well, we're already, dude. I'm already down bad. We are already down bad. Yeah. What happens if you comment this out? What happens if you comment that out?
I just released my first game. A mobile puzzle game. If the chat wants to check it out.
Well, thank you, Alan. That's awesome. Congrats. Congrats on releasing your first game. Okay, so I don't understand how or why that works. Are we breaking? Because it doesn't look like, let's see, hold on, warning. Draw arrays instance program has no frag output at location 0. The destination draw buffer has attached image, and its color right mask is not all, let's see, is not all false. And draw buffer 0 is not none. Bro, I don't even know what that error means. Mr. Dewey, thank you for that, dear one. What the hell does that even mean? All right. Anyways, there are multiple ways of constructing a vec4 type. Try to discover other ways. The following is one of them. Yes, okay, so yeah, okay, so we already saw that. We already saw that with this one. So you can do a vec2 in a vec4. And so that must mean, I assume there's not a vec1. So you can do vec3, vec2. Okay, clear color is blue. You mean clear color is cornflower blue? Right? Okay, anyways, although this example isn't very exciting, it's the most basic example. We are changing all the pixels inside the canvas to the exact same color. In the following chapters, we'll see how to change the pixels by using 2 types of input. Space, the place of the pixel on the screen, space, and the number of seconds the page was loaded. Oh, hell yeah, brother, man, girl. All right, hold on. Space, 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 base, space, 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 space. Space. Space! Space! I'm not sure how it happened. This is just what happened in my head. So sorry, I got lost. I got ADHD'd out of my mind just then. I got ADHD'd out of my mind, and this song just wants to play in my head. All right, next. Uniforms. So far, we have seen how the GPU manages large numbers of parallel threads, each one responsible for assigning the color to a fraction of the total image. Although each parallel thread is blind to the others, we need to be able to send some inputs from the CPU to all threads. Correct. Okay. So how do I pass in inputs? Interesting. Because of the architecture of the graphics card.
Welcome to Costco.
Oh, thank you.
love you.
Etas. Yeah, I did that. Because of the architecture of the graphics card, those inputs are going to be equal uniform to all threads and necessarily set as read-only. In other words, each thread receives the same data which can be read and cannot be changed. Okay, these inputs are called uniform and come in the most supportive types. Wait, supported types, not supportive types. Hold on 1 second. I have a kid entering, so I'm going to be right back. All right, so we got some supported types. Okay, we have float, vec, mat. I'm not sure what a material is. Finite singularity, thank you, dude. Finite knows what he's doing, and this is like Finite's realm. Sampler 2D and sampler cube, okay. I don't even know what that means. It's a matrix. Oh, that makes perfect sense. Yeah, I stupid. I was thinking material, and so I'm just like, I don't really know what U's and V's and materials and stuff like that is, but okay, this is exciting. Uniforms are defined with the corresponding types on the top of the shader. Wait, hold on. Uniforms. Are uniforms supposed to be arguments? Okay, so that's what a uniform is, right? Uniforms are, okay. Canvas size. Okay, so a uniform. Just to make sure I understand this correctly. Let's see. Is a uniform in GLSL an argument to the shader? Yes. A uniform is conceptually similar to an argument to the shader, but with the key difference. It is a global variable set by the host of the application. JavaScript or C++. JavaScript going first. JavaScript going first when I say GLSL is actually insane. This is insane behavior by ChatGPT. Let's see, it remains constant for all invocations of the shader during the draw call. Okay. Key characteristics, a global variable uniform. By the way, this is what I consider proper usage of an AI, right? Soy Jippity, dude, Samuel Soy Jippity Altman is really injecting the soy into the population to make us weak and susceptible to government control. I swear. All right. That was probably the most unhinged thing I've ever said in my lifetime. Global variable. Uniform variables are accessible in both the Vertex and fragment shaders, if declared in both, without being passed to the function arguments. Constant per draw call. Their value does not change during the execution of the shader. Okay. Set by host application. Okay. So that's what so this is a uniform is a variable. This is the only right way to use it. Yes, I agree. Right? Okay, nice. They're all telling me this. Yes. Okay, awesome. Okay, cool. Cool. We got a Captain Holt writing shaders over here. I'm not sure who Captain Holt is, but let's go. Okay, so that feels good. Okay, we now know that. So you can picture the uniforms like little bridges between the CPU and GPU. The names will vary from implementation to implementation, but in the series of example, I always pass them as U time. Okay, interesting. So prefix them for visual clarity. Okay, very cool. Thank you. Kira Dus. Dude, I finished my ray tracer yesterday for class in computer shader. Now I did. Oh, that's cool. That seems really cool. Oh, by the way, I feel like I forgot to do something.
Shaders, hell yeah. I love shaders. If you have any questions the book doesn't answer, I'd love to try and explain.
Awesome, yeah. You'll be here, and so I'll definitely mark you as somebody I will look for, okay? Hi, Eve. By the way, shout out to Finite Singularity. If you do not know Finite Singularity, A, nice fella, but B, he also is like super good at graphic stuff. Like he knows what he's doing out there. All right, time in seconds since the shader started. U, resolution, billboard size, where the shader is being drawn. U, mouse, the mouse position inside the billboard pixels. Okay, so what you're trying to tell me is that I could do some cool stuff. So how do I pass these things in? Let's see how we pass these things in. Okay, hold on. Uniform U time. Let's go like this. Since I don't want to do that, let's go like this. It's, how do you do that? Uniform float. Let's call it U, not that one. Let's go vec3. No, wait, vec2. Uniform, this is called, how about UPOS? I wonder if I can do that. Can I take in a mouse position? So what I don't understand is how do I pass in positions from said, from into this program, right? Because there must be something that you compile, and then you compile these vertex shaders and all that. Then you attach these things. Where do you call these things? Vertices. Okay. Bind buffer. Buffer data. Enable this. Draw. So what I don't understand is, okay, so let's do this. Before I go any further with these, let me just try this. How do I pass in mouse position into a fragment shader via Canvas? Canvas, or via, what is it called? Web GLSL shader language, right? Wiggles, wiggle. What's the word do you say for this? Bind uniform or something in a wiggle. Okay, let's see. On a let's see. I have the following code. I just need an example. What does this look like? Okay, so I think I understand this. Just what does it look like? Let's just go like that. Even though this code sucks, right, it doesn't really matter. How do I set UPOS, right? Nice. Question mark. From JS. What's the thing? In WebGPU WGSL, you don't use uniform as a traditional GLSL. Instead, you use uniform buffer or storage buffer and pass data like UPOS, mouse position. Below is a guide. Oh. Group 0, binding 0, var uniform, UPOS vec2. This doesn't seem like what I'm looking at is the same thing. Okay. Is another shader language. Oh, gosh. Okay, I'm not using that one. Okay, I was wrong. I am not using a web GPU. WGizzle. Okay, Wajizzle. I like Wajizzle. I am using WebGL. Can you redo the previous question, but with WebGL? Question mark. There we go. All right. So does WebGL pretty much use GLSL? Is that what I'm hearing here? Distance. Oh, nice. Okay, so there's a distance formula between my fragment chord and my position. All right. I think I get this. Hey, by the way, Kick, appreciate that. All right, let's see how they call it. Good to hear you. Hey, I appreciate that. I asked ChatGPT to add MF at the end of every time. Oh, really? Okay, that seems kind of fun. All right, so we have our full screen. Create buffer, do this, static draw, get attribute, program A position. What the hell is an A position? There's a UPOS here, but what is an A position? Oh, look at this. Get uniform location. Get the uniform location. Get bounding box. Okay, so we can do a uniform 2F UPOS. Oh, so you get this location and then you set the location. Nice. Okay, I feel like I understand that. I feel like I get that. Okay, Flip mentioned, TK2473, thank you. There's no way it's been 6 months. Well, it has been. Okay, so we can take that little bit. I think that makes sense. Honestly, I think that makes sense. We're kind of getting to the end of this because this is kind of feeling really annoying. My guess is that... Now, I guess the next thing I have to kind of figure out is... Oh, nice. Okay, that's it. Clear color, clear, draw arrays, GL triangles. So I still, obviously I have lots of questions. Okay, so this is the thing that I wanted to figure out. It's these two right here. So draw arrays is that right there, which means that this right here can go away, right? Because we don't need that, right? So we don't need that, and we really want our UPOS, right? Okay, so this must be some sort of handle, is my assumption, is that this thing, whatever that thing is, this is some sort of identifier or whatever to be able to go in and grab this the uniform position. And so that means I can update the uniform right here. Okay, and then this thing will just draw it over and over and over and over again. Okay, so which means that if I go up here and I go into here, I'll go like this. That means I should be able to do something in the following. I should be able to get, how do I create a variable in this? How do I create I think they created a variable up here. I can do a float distance to mouse. That's kind of what I want to do is distance to mouse. Okay, so I can do a float dist to mouse because this is what I wanted to do was this exact thing. And then I wanted to do like some amount of red, right? So let's go like that and let's go, I guess I could go right here. We can get red. I don't really need red. I just wanted this guy. Okay. Crazy code that this person's writing, absolutely no spaces, is insane. String programming, insane. Let's go vec for red equals this. I assume that's how you do it. Let's go float dist equals distance, right? It's distance. And so GL frag chord XY must be a vec2, right? So if I go GL frag color, XY, gotta be careful saying the word frag over and over again. That must be a vec2. XYZ must be a vec3. XYZW must be a vec4. I feel like I'm close to that. I feel like it's something like that, right? Are we getting close? So then I could do UPOS. Okay, so there we go. So I get the distance, and now what I want to do is I want to maul this vector, right? There must be some sort of vec multiplication, I bet you. Vec2, let's see, vec4 scalar multiply GLSL function. What is it? Yeah. Oh, I can just, oh, nice. I can just multiply it. Cool. So that means I should be able to go like this. I guess, ooh, next question is, I need one more uniform, which is let's go like this. Let's go uniform, window size, right? I feel like I need a window size, which should be the size of the screen. Yes. Frag color is the color, not position of the pixel. You're calculating, ooh, wait. Oh, did I do that wrong? Frag chord. Oh, okay. Chord, okay. That's the coordinate. That's some thing that's obviously set in stone. One would assume that that's kind of like set in stone. And anytime there's like a distance, anytime there's a distance, or anytime there's a window change, all the chords get updated, and then I assume that's kind of like a one-time operation, and then you just have those kind of like static frag colors, right? And so ultimately what I want to do is I want to do something that looks like this. I want to go red equals red times dist, but that's not quite right because I need to normalize dist now to the window size. Let's go like this. Let's actually call this thing a float, and let's just call this window diag, right? It's like the window's diagonal. And so can I go like this? Window diag. Theoretically, that should always be between 0 and 1. Not really sure. I don't know. But I don't even know. All right, so let's grab this thing, and I'm going to go grab this and go window diag. Grab that thing, go window diag. Let's just go like that. Whoopsies. Window diag. Please just let me do this. I know this is ridiculous. Get bounding rect. And go const GL uniform 1F? Hell yeah, brother. Window diag equals that'd be right? Am I crazy? That's C, right? Yeah. Right? Ooh, this next song is a banger. All right. So if I've done that all correct, which I did not, okay, red is not a function name expected. Okay. All right, red equals that. Okay, so I must have goofed this up somewhere. Oh, I goofed it up by doing that. Okay. Ooh, damn. I thought I had something there. I thought I had something. I didn't have something. Okay. So I in fact did not have something. Too many pluses. Height should be multiplied. I'm pretty sure height was in fact multiplied. Right? Let's see. Const dub equals here. We'll go like that. Oh, you're right. You're right. Okay, you're right. Right? That should be dub plus HH, right? Yeah. Oh, I was really hoping this was going to work. Okay, so that's not working. That is in fact not working. That is not working. That is not working. Wait, what is the distance? You're getting shady. All right, hold on. Shader for the browser. Yeah. Too much rect. Dude, am I getting rectum going on here? You want to see if the value is passed. Just render the distance. Yeah, that's what I'm doing. We're just trying to render some distance. Clap. You need to push your uniforms for each pass. Do you? Are you sure? You need to push it for each pass? Oh. Let's see. We got... Yeah, no. There's semicolons on each one of these. There's semicolons in each one of those. Frag chord is normalized. Oh, frag chord is normalized? Okay, so holy shit. That's confusing. Okay. Is in pixel coordinates. Okay, pixel coordinates. Okay. I'm in pixel coordinates. Shouldn't you do that in the vertex shader? Then the vertex. Okay. Again, you're saying, see how you're saying things that I don't understand. Okay. Okay, hold on. You can use Shader Toy. It's a good starting point. You can see as your changes in real time. Well, my changes are in real time right now, right? That's not the problem we're having right now. Remove the window diag for a second. Here, how about this one? I'm gonna go like this. I'm gonna set the window diag to 1. How does that sound? Let's see. After reporting 32, no further warnings will be reported. Draw arrays instanced. Vertex fetch requires 6, but attributes only supplied 3. Okay, so obviously I got myself a bit of an error. Not really sure what that means, but my guess is that I'm going to go like this. I'm going to set this as 0, 0, and then I'm going to set 1f upos, not upos, window right, just for fun, 1, right? Because if you're telling me it's a space between that, then I don't have to worry about that. Yeah. We're not in Web Kansas anymore, Dorothy. I know. Okay, so it's not even red up here. Okay, so it's not red up here. Okay, so I don't get that. What's your build on POT? Right now it's a little sparky. Let's see. I'll put this color, geofrag color XY divided by 1,000 to see the gradient. Ooh, great call. Okay, yeah, that's a good call. All right, let's go like that. Let's try that bad boy. Let's go like this. Vec4, GL, frag chord, XY. Did you say divide by 1,000? Did you do 1.0? I don't really know what the fourth chord is. Yeah. I don't really know what that last one is, but I'm just going to assume it's a 1. Floating point suffix unsupported. Oh. I don't get that one either. I don't even get that one. Okay, so that's not it.
Welcome to Costco. I love you.
Thank you. How about just that? Nope, I don't see that either. Let's get rid of that thing. Let's get rid of that thing. Hold on, we're doing this. We're one thing at a time here, okay? We're trying to understand the world, okay? Too many args? Check your vertex array. Vertex is this. Let's see, it defines a full screen triangle. Oh my gosh. Okay, so first off, I'm doing something like this, right? To be completely fair. I effectively am doing this. -1, 1. 3, -1, right? No, actually, it's not like that, right? Because I thought I saw 3, 3 in there. Hold on. What is it? No, I was right. Hold on. Is it Y? And then doing a -1, 3, right? And then my screen is, right, so this would be 1 and 1. And then my screen is effectively 1 by 1. Is that correct? Is that what this full screen triangle is actually happening right now in our brain? Isn't 0, 0 at the center? I would assume 0, 0 is top left. I just make the assumption that 0, 0 is right here. And this is positive and this is positive. That's like,
Welcome
that's
to
my
Costco.
assumption of how this works.
I love you.
Yama Cake, appreciate that. Center. Oh, sweet summer child. Yeah, no, trust me, I get this. 0, 0 is center, huh? I've always used 2 triangles to go full screen, yeah. I've never done this. Okay, so to be fair, does that mean for me to do this properly, I'd want to go like something like this? 0, 0, 0, 0, 0, 1, 1, 0. Hold on, let's just see what this does. I just want to see what this does. Okay, let's get a more normalized thing here. Hold on, let's go like this. 1, 0, 0, 0, 0, 0, 1. I still don't know what that fourth one is. I know it's W, but I don't know what W is. Vertex fetch requires 6. Oh. You're right. 0, 0 would be right here then, right? Yeah, you need next level autism for making shaders. Last time I tried, it hurt my brain so much. Hey, I'm just trying to understand something, okay? Vertices, draws, okay. So that means if I wanted it to work out, let's just go like this. Now, I want to draw these two, I want to draw these rectangles in different positions. Or these triangles in different positions. Okay. So this puts it down here. Okay. I'm laughing like a Brazilian, and it's crazy. It's actually crazy that I'm doing that. Hey, thank you very much. A bunch of tree. Okay, so that means if I understand this, that means to get this top point would have to be -1, 1, right? So it'd have to be -1, 1, which means then I'd have to go 1, 0, or 0, 1. I want to say that's true. And then this bottom point would be -1, 0. Okay. Okay. I'm not sure if I can just keep on doing that. Oh, is this way negative? Top left is -1, 1. Okay. Okay, so that means if top left is -1, 1, that means this is that. And that means bottom left would be 1, 1. And so if I've done this all correctly, it doesn't allow me to write more of them? Did I not? Here. Oh, that's because this side would be, that would be -1, 1. Or it'd be 1, -1, right? Oh, sorry. I realize my hands are going backwards. It should be -1, or sorry, that'd be 1, -1, right? So that'd be 1, -1. So that should put that triangle over on that side. Okay, hold on. Okay. All right. So let me understand these coordinates. So my head would be this as 1, 1, this as -1, 1, but that's not the case. Instead, top left is -1, 1, which thus must mean that this is 1, 1 down here. Correct? Oh, top left. Oh, marmalade. So that means 1, 1 is right here, which makes 1, 1 right here, which means that to do this, I'm going to need to draw a triangle right here and to draw a triangle right here. I'm going to need negative 1, 1, negative 1, 0, 0, negative 1, right? Or sorry, this would be negative 1, 0, right? And this is 0, negative 1. Am I at least getting X and Y's correct? Wait, is this Y also? And is this X? All right, hold on. Let's just take a break for a quick second. Okay, Y is still up. Good. Okay, Y is still up. Whew. That would have been okay. That would have just. I would have been like, well, I'm too stupid for this. I actually am too stupid for that. Okay. That would have been just the end of my shader career right there. Okay, so that must mean that it's this. Correct? All right. So if I've got that correct, that means I'm going to go over here and I'm going to go negative 1, 1.
Welcome to Costco.
That, and then these two.
You.
And that should put it... Okay, so that's putting it right there. I feel like you told me 1, 1's right here. And negative 1's right here. Yet here I am not having that. So it looks like bottom left is negative 1, 1. This is bottom left. And, oh. Bottom left is 1, 1, and this is 1, 1. You guys suck. Okay. Oh, top right's 1, 1. That's perfect. Like, this is exactly what I wanted. This is normal. Oh my gosh, this is totally normal. This is totally normal. Steel Tormentor, appreciate the 6 months tier 1. This is completely, yeah, it's math coordinates, not paint coordinates. Now, okay, now we're making sense. Okay, so that means if I wanted to flip it the other way, I'd have to do something like this. Right, and that would flip them right there. Okay, you got me, Satan, with that one. Satan, you got me. Okay, so 1, negative 1. Oh, wait a second. I just did the same thing twice. I just did said same thing twice. So if I did that, that would produce that. Okay. Okay, we're going now. In OpenGL, there we go. All right, hold on. We got someone that has claimed expertise and is telling me some fun facts. Hold on. Okay, this is NDC space, normalized device coordinates, which actually varies between graphic APIs. Okay. But since I assume that for WebGL this acts uniform. Can we say that? Is that fair? Yes. Okay, so that would mean, hear me out. If I wanted to do something like this, let's re-get this bad boy in here, okay? So now that we understand the color space, if I wanted this uniform vec2 pos, I would jump down here, get that bad boy, and let's do this one. Let's do a vec2 position of my mouse, okay? My vec2 position of my mouse, and I'm going to normalize my mouse to this space, okay? I think I got this. Okay, so what I'm going to do is I'm going to have position location. I don't know what that is, so I have my UPOS. Wait, what is UPOS? Can you pos me? Okay, precision, medium float. This is the position of the mouse, correct? Okay, that's what I'm going to treat it as. So I got the position of the mouse. The position of the mouse is going to start off in the center. Okay, so that's center. I'm going to set the position of the mouse to be a little bit different than this. I'll set the position of the mouse to be, hold on. So I'm going to have to first get center, right? Const center equals rect dot width, right? Center is 0, 0, which is going to be, it's going to be width divided by 2, height divided by 2, right? So that would be like the center position. So that's 0, 0. Correct? Correct. So that means my position is going to have the event. Okay, this music is way too loud. My left is 0, right? Okay, there's my mouse X, my mouse Y. That doesn't matter. We'll just keep them like that. My X is 0. And so that means my position should be the following. It should be okay, so this is 1. This is 1. So that means if I took center, if I took mouse X minus center X, then this will become positive this direction, right? Okay, just tossing things out there. So that means if I go like this, if I go center X, if I go mouse X minus center X divided by rect, here I'll go like this. Const, width half equals rect dot width divided by 2, height half. I guess I don't really need center anymore because I'll just have them right there, right? I think that just makes more sense, right? So that'd be, if I take my thing, half the width divided by half the width, and then do the exact same thing right here, half the Y divided by half the Y, then that should be a nice uniform position between hopefully -1 to 1. Get wrecked. Dude, I'm trying to get wrecked. And that means I'm going to color this thing according to its distance from that position with red.
Welcome to Costco. I love you.
But that does pose a problem because I also have a negative. I also have a negative. So I guess I'd have to go like this. If dist is less than 0, is there an absolute value? Can I go apps? I'm just gonna try it out. Maybe absolute value exists. I don't know. Hey, thank you. 1, 2, 3, 4, 5, 6. Appreciate that. And Corloziden and Steel Tormentor. Thank you. Okay, so we did get yellow, which is not what I was expecting. This is not what I was expecting. Not at all. This is not it. And so that, well, what is this answer? Because that was, the width should almost be 1, right? Yeah, look at that. It's almost 1. That was good. I mean, that was good. And I came down about half through the page, which means this thing is about negative that. So I came down about, I came down right around here. So that's about right. Oh, but this dist. Oh, but that's a dist. That's wrong. That's wrong. What is that? All right, so how do I take, I guess I have to just normalize. Can distance be negative? Yeah, distance could be negative, right? You're doing the draw call once? I'm doing the draw call a bunch of times, right? So here's the draw call. Is there more draw calls that are needed? Like, is there some other draw call that I'm incorrectly doing? You need a game. I have a game loop right here. This thing is rendering over and over again. This is rendering over and over again. Your frags aren't in NDC. They're in raw pixel XY. They're not. They're in NDC, right? Wait, hold on. Your frag chords aren't in NDC. Oh, what are my frag chords in? Oh, I thought frag chords were between 0 to 1. Okay, yeah, what is, oh yeah, we're gonna, that's it. Okay, what is geofrag chord XY? Geofrag chord XY is a built-in variable in GLSL that provides a window space coordinate of the fragment being processed by the fragment shader. Key point, fragment this one, type, vec4. XY are XY window space coordinates. Z is the depth value of the fragment between 0 and 1, is the clip space W component used in perspective division. Specifically, corresponds to the horizontal coordinate of the fragment in pixels. Corresponds to the vertical coordinate in pixels. 0, 0 is typically the lower left corner of the viewport. Hey, thank you, T2. Appreciate the raid. Let's go, T2. Thank you. Thank you. Normalize the viewport size. This could be a cool example. All right, let's try this. Why not? Right? So if I've done this correctly, oh, you're right. I'm definitely not redrawing it multiple times. On window resize, I'm definitely not redrawing it. All right, so that means it should get very red as we go this direction, right? No, wait. No, not red that direction. Wait, yeah? It's red, green, blue, right? Red, green, blue? Red, green, blue. So why is red very high right here? Red to the right. Yeah, but it seems like red to the downs. Okay. Well, I suck at this. Okay, let's go back to the shader language. We tried some exploration. I clearly failed. That's okay. Let's see what we have to do here. Okay. Okay. I tried to be smart. Turns out I'm stupid. Okay. Fair, factual. Let's just keep on going now. We played for a little bit. All right, as you can see, GLSL has more surprises. I'm feeling quite surprised as you mention it, you know? The GPU has hardware-accelerated angle, trigonometric, and exponential functions. Some of those functions are sine, cos, tan, asine. Hey, cos, tan, power, squirt. Oh, nice. That's some squirting. You can squirt, you can sine, floor, seal, fract, mod, min, max, clamp. Okay, cool. And now you're just rushing it. Hey, I'm just learning things. We're learning things as we go. Now it's time to, again, to play with the above code. Slow down the frequency until the color changes become almost imperceptible. Speed it up until you see a single color without flickering. Okay. So I want to pass in the time. Okay, okay, good. This feels like something I could actually do here. Okay, so whoopsies. So let's take it a time. And what I'm going to do is I'm going to go like this. Const now equals start equals date.now start. All right, and then let's go like this. Let's see. Dir equals date.now minus start. Yeah. That means we can take one of these things. We can take this thing in here. I'm just going to erase this. You're dead to me. You're dead to me. You're dead. You're dead to me. U dot, what do we call it? A U dot time. Okay. You got that time. U time. Get uniform. Do one of those. Okay. Oh, that's why I could draw multiple of them. Because this is how many triangles I'm drawing. Okay. I've been watching your Dev Productivity 2 on Front End Masters Program. Great course there. I've also been watching your Algo course. Hey, thank you. Okay. I told you, hey, dude, calm down. Calm down. Of course you told me you're used to it, okay? This is a lot of information to take. This is a lot of effing information to take in, okay? Can we just all calm down for a second? This is a lot of freaking information to take in right now. Okay? One just does not simply take it like a man. Okay? I'm not taking it like a man right now. I'm taking it, I'm very gentle and I feel hurt. Cool. Okay, so that's so if I were to multiply this by 10, that would effectively make it into what appears to be a single color, or it just is out of control, right? But if I were to divide this by every second equals 1 pi, right? So how do we do that? I take all this thing and normalize it to a pas. So would I go like this? Would I go let dir equals dir divided by 1,000, right? Multiply by math.pi. I think that's right. Okay. Turns out I'm not too dumb right there. That's not dumb right there. So that means I could do half of the sine wave. There you go, by slowing it down. Okay. I'm not turned dumb right there. Okay. All right. That makes sense. Genius divided by pi. Skateboard ramp Wojak. Is this how we're living our life? Is this dude? I got no skateboard head Wojak. Where's my dude? What? I have Wojak in there. Dude, I must be eating up all my memories right now. This thing is going, something is going real slow here. I don't know what's going on, but it is going slow. Copy image. There we go. Here we go. We're going to take that one, go like this. And post. And post. That's what it feels like. 1 hour of shader programming, and this is precisely what I feel like. Okay? I need you to know that I'm proud. Well, thank you. The boilerplate is pretty important to understand what's happening. Yeah. You should use shadertoy.com. It's all the OpenGL. Yeah, but I don't really need all of that, right? Like, I don't need all that. This is easy, okay? This is everything that I want in here, and it's allowing me to interact with the different variables, understand what the variables are, allowing me to hook into things such as mouse position and all that, and really try to get it. Hey, Regarded Glizzy, let's go. Appreciate that, Regarded Glizzy. Okay, so let's try something different. Can we all agree we should try something a little bit different? And so if I understand this, Regarded Glizzy, I appreciate that. So if I understand this correctly, I should actually be able to go like this. I should be able to take, so I think I understand this thing correctly, okay? Let's go up here, and let's go back here, and let's go down to this. I'm going to just yank that for a second, and I'm going to take that. I'm going to take this, and I'm going to paste this in here, and I'm going to yank this, and I'm going to paste this in here, and I'm going to go window dot resize. All right, don't worry. Don't worry, I'm going somewhere with this. Don't you worry. Actually, I don't even need to do that. I can just go right here and go that, there we go, mouse move. And I'm gonna go like this. Let mouse chords equals, let's see, X 0, Y 0. Trust me, I'm doing something. Trust me, I'm being clever as shit right now. I guess I should probably use the rectum, shouldn't I? We'll just ignore it for now. Okay, so I'm going to do this. I'm going to update my chords based on this. I don't think I need that because I think I can just go like that, right? So for that, I'm going to jump in here. And if I've done this correctly, I can take the bounding rect. I can go, let's see, counts with perk equals, watch this. Are you ready for this one? Rectum, let him cook. Just let me cook. With perk is going to be rect dot with, let's go like this. Mouse chords dot x divided by this. H perk y height. And that should be that one multiplied by all right. So if I've done this correctly, which by the way I have because I'm an actual genius. Yeah. Yes. That's not what I was expecting. Yes, but I didn't expect that. I thought this would be a value between 1 and 0. Console.log w perk h perk, which meant oh, wait a second. Pi. Oh, shit. Yeah, no. I see what went wrong here. It should be divided by 2, right? Yeah. Right, because a sine wave is like that, right? So this is the 1 pi thing. So that means halfway through the screen I should hit the 1 pi. The other half of the screen I should hit the other at 2 pi, right? So dividing by those both should make it so that I should go dark to not dark, right? There we go.
Welcome to Costco.
Center gives me the brightest. This gives me the darkest. Yeah, shader coding time. I missed the beginning. Yeah, well, don't worry, Vipitus. I am pretty stupid. Okay, how we doing? That looks pretty good, right? Okay, I kind of got a little bit of it. Just like the world's tiniest little bit. Are we okay with that? Right now, I'm feeling like a regarded glizzy, right? All right. Hey, YouTube, how you feeling about Prime? Do you ever narrate your work when you aren't streaming? No, I do not. It looks like he's making some sort of communist propaganda. I am. We are literally just like 4 triangles away from a hammer and sickle. Like, honestly, we are this close to a hammer and sickle. It's so close. Why JavaScript? Because I'm making a Canvas game. YouTube, how you guys doing over here? You guys doing good? You're playing with us. Do you think there is potential for new streamers to make something like your style of streams and videos? Yeah, of course. I don't think I somehow have the exclusive on anything. The thing is that there's room for there is room for anybody to start streaming what they love. The question is, what is the size of that audience? I believe anybody has an audience. It just might be smaller for some and larger for others. Like an easy example is Thor versus me. He obviously has a much bigger audience. His style, I think, attracts more people. He's really good at explaining himself. I'm not that good at explaining myself. Obviously, he is clearly a really good-looking Fabio-like character. I kind of look like a Muppet. So I think he has it all. He has the voice, the looks, and the ability to talk. I don't got, got a lot of those, all I got is good Vim motions, okay? It turns out the audience is much smaller when you're good at Vim. That's all you got. I got Vim. That's all I got. That's all I got is Vim skills. And he worked on an oil rig. Yeah, he worked on an oil rig. I'm practically attracted to him right now just saying that out loud. I prefer Diet Charlie Day. Okay, that hurts a little bit. Thank you for that one. Thank you. Vim skill tree too deep. Yeah, it's fine. We still watch you. Yeah, Vim skill tree too deep. If this does not have 1 million likes, if I don't have 1 million likes on this one, I think this tweet failed. Okay, because this is obviously the most true statement of my lifetime. And anybody who's done this for a moment makes you feel that. We're here only for the Vim self-help group. Exactly. This is a Vim self-help group. Okay. So I feel like we did this successfully. I understood this and passing in stuff, and I have a render loop and all that. Okay. Oh my gosh. Oh my. Oh, dude, I'm frag cording. I'm frag cording so hard right now. Oh yeah. We're frag cording. Let's go. All right. In the same way GLSL gives you a default output vec4 frag color, it also gives you a default input vec4 frag chord, which holds the screen coordinates of the pixel or screen fragment that the active thread is working on. With vec4 GL frag chord, we know where a thread is working inside the billboard. What? We call the front page of Netflix, the first big one, we also call that a billboard. In this case, oh gosh, what are we doing? Netflix stock, how are we doing? Are we stonking? Oh, we are stonking, boys and girls, we are stonking. We are stonking, always up, just stonked out of our mind. Let's go. A lot of we there, it's royal we, okay? I'm a shareholder, that makes it a we, okay? So you can shut your dirty whore mouth, that's a we. All right. In this case, we don't call it uniform because it would be different from, let's see, thread to thread. Instead, GL frag chord is called varying. Okay. All right. So we have a uniform vec2 resolution. We have a vec2 mouse, and we have a vec2 time. Oh my gosh, they're doing exactly what I wanted to see. Holy cow. This is so exciting. I've never been more excited in my lifetime. Vipitus. A Vectua? That's a Vectua. All right, I need to go get, the truth is revealed, absolutely. I need to go get some more water so that my voice cords don't explode into actual sand. Had to talk to the old wife. By the way, she's looking good. Hey, thank you. Your boy, shithead. Hey, your boy, shithead, how you doing? I'm not misreading that one. Why do we have to know that? Because it makes me feel better than you. Okay, so resolution.
Welcome to Costco.
Okay.
I love you.
Okay. So that means if we were to do this now. Okay, so let's do this. Let's do this bad boy. Thank you, chat is cute. Are they? See, yeah, get it? Shith Eid. Dog, your name's Shithead. Don't even try that with me. Okay? That's enough of that music. Don't even come at me with, oh, it's Sheath Eid. Prime just made he not also cute. Wait, what? Though regard? What the hell? It took him 10 seconds to process. It's for the memes? I don't believe you. It's not for the memes. I want something that makes me happy. All right. Actually, what I think of is clearly I am right. Actually, I like. Do you Bruno? I'm not sure what Bruno even means. Actually, something about being a virgin. Okay. Anyway, so let's try something different. Okay, this is what I'm thinking here, boys and girls. Okay, boys and girls. Okay, we're gonna do this. We're gonna make this thing happen. I'm gonna erect them. No, not gonna happen. Destroyed them. That's what's going to happen. All right, so let's go like this instead. I want to do something a little bit different. I want to make it so that as I move, did I see Aaliyah? Hey, Aaliyah, how you doing?
I love you.
Hey, Aaliyah, how you doing over there? And thank you. I've never done any proper VJ stuff. Oh, giving the bro a VJ? Giving the bro of a JJ, that's how you highlight 3 lines of code. 16, 16, 16, 16, that's a lot. Did you do 16 16s? You did 16 16s. It's 256, crazy. Well, now's your chance. You can make one in a shader language. It's the closest you'll get. Oh, I'd have to get good at triangles first. And bro, I'm not good at triangles. I'm pretty sure he's raw dog on WebGL. Yeah, with the most scuffed render loop ever implemented. That's not a scuffed one. Dude, this is not a scuffed one. Clear, draw, next animation frame. That is not a, first off, that is evidently not a scuffed render loop. Okay. That is ridiculous for you saying that that's a scuffed render loop, which, by the way, my platformer, I know how to make now. I could render my platformer using WebGL and shaders now. I'm feeling pretty good. We're feeling confident. Okay? I'm feeling confident. I'm gonna get that toilet riz going. I got toilet aura. All right. So this is what I'm thinking about. Okay. I got. So that means I need to do the. Okay, so let's add some new coordinates. So what they're doing here is they're doing the following. They have time still in there, but they're not even using time. Okay, that's how you make a bad script, buddy. Okay, you made a bad script, buddy. All right, let's go like this. Vec2, U res, okay? And then we're gonna go Vec2, and then we're gonna go U position, right? So one is the resolution, one is the position. So we're gonna take the GL frag, and we're gonna get the resolution from the XY. Okay, so you can even see right here that 0, 0 is right here, because that's, ooh, baby boy. All right, color. I'm not sure what happened there. It just felt right. It felt right in the moment. I don't know what to say. So that should be GL frag chord XY divided by U res. Right? Now that, go up here and go, I should be able to just hit it with the color, which should be 2, which means that's that. Okay, right? Yeah. Hey, Code Girl. Hi, Code Girl. If I can, using it as an applicant, then I prefer to go straight to Unity. I don't want to go straight to Unity. I'm shading right now, okay? Hi, Eve. I'm shading. All right, so we're okay, so this is going to use my resolution. So let's first start with that one. Can we all agree that that's a good first start? Good first start. Good first start. Okay, so let's take this thing. Let's go right here. Let's go in here. Let's go window. Let's add event. Let's go into resize. Let's take that one in. We got a resize event. This little event right here should be a UI event. And then I guess what I have to do is I have to set, where's my canvas? We're going to want to yank one of these, right? And I'm going to yank that in there. We're going to take that bad boy in there, and we're going to do this, and we're going to paste this in here, and we're going to have it number 2, and we're going to jump up here and find my U position, U time, go U res. There we go, and take that, go U res. I don't know why I renamed it. I could just... And then go in here, U res is going to be... shoot, let's go... window.inner width, window.inner height is my assumption. There we go. So every time I resize it, it should also cause that thing to be bigger. Now when the mouse moves, we're not going to deal with this yet, okay? We're not going to deal with this yet. We're just going to go like that for now. All right? Perfect. So that means my triangles should get bigger as I move. Yeah?
Welcome to Costco. I love you.
Triangles are in fact not getting bigger. Oh, I need to set I need to set something else. Let it be. Let it be. Are we singing here? Let's see. So I obviously set the canvas, but I'm not setting the context, huh? So I need to do the GL viewport. Yeah, there we go. GL viewport. GL viewport. GL viewport, set viewport method. Glint. What's a glint? You can glint these nuts. Got him. All right, 0, 0. And then that one. Glintstone, that's dude, Glint is giving me some serious Elden Ring vibes going on right now. Oh yeah. Oh, yeah. I don't know why it starts off yellow and then gets just completely stupid. Let's go. Okay, so this is looking good. Oh, yeah. Triangles. Oh, baby. Oh, by the way, Jaeger Scripts, thank you for that Twitch Prime. I'm getting... Dude, we're getting it. We're getting it. We're moving. Okay. Okay, good answer. Good answer. Hey, good answer. Good answer. Okay, I love coffee and milk. Hell yeah, brother, man, baby, child. Let's go. Okay, so this is what I'm thinking here. Okay, are you ready for this one? Are you ready for this one? This is what I'm thinking. I am hip thrusting. Okay? We're gonna go like this. We're gonna call this the norm. The normal, like this is like the pixel's normal value, the eigenvalue, whatever it is. Okay, so then after that, I want a color, okay? We want a color. And this is what I'm thinking. I'm thinking this. We should take our norm pix, and we should take our U position and divide it by our U res. Yeah? 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 That's what I'm talking about. That's what we're talking about. That's what we're talking about. Good answer. Good answer. Oh, that's such a good answer. So we're going to take this thing and we're going to go like this. GL uniform to float. Yeah, to float. Too fast, too floatious. We're going to take that one and we're going to go like this. Event.client X, event.client Y. Right? And so if I've done this correct, we get a cornflower blue, because cornflower blue is normal. And then right afterwards, we get nothing. Fuck. It must be because I'm hitting a 0 here, huh? I'm hitting a 0 here, right? You are not setting the initial value? Ooh. Hey, there must be a 0 in there. There must be a 0. You riz? Oh, I'm getting rizzed out of my mind. All right, so I'm just gonna go like this. It must be that there's a 0 in there. Okay. Oh. Oh. Ooh. And then I think if I go all the way up here, I will break my shader.
Welcome to Costco.
Did I break my shader? Dude, I'm dividing by 0. Dude, shaders dividing by 0, not a problem. Yeah. Let's go. We got it. We got it. Where's my divide by 0? Okay. Okay, Prime, let's see, whoa. Prime, as a grade school teacher, would be hilarious. He just dances while solving problems himself, then yells, good answer to the class. Good answer. That is okay. That's a good answer. Good answer. Hey, thank you very much, Shungir. Shungir. Karen. I'm a genius, Karen. I just knew it. I was the smartest man. And my mom has always been right, Karen. I could feel it. I could feel it coming. I knew it. All right. Shaders looking hot. All right. And above, we normalize the coordinate of the fragment by dividing it by the total resolution of the billboard. By doing this, the values will go between 0 to 1, which makes it easy to map from X to Y to the red and green channel. Yes, okay, I get this. In Shaderland, we don't have too many resources for debugging besides assigning strong colors to variables and trying to make sense of them. Yeah, I could tell. I can tell. You'll discover that sometimes coding in GLSL is very similar to putting ships in a bottle. Is equally hard, beautiful, and gratifying.
I love you.
I don't want to put a ship in a bottle. Kill Tastic, thank you very, very much. You still doing ALC? Dude, I'm so distracted by... I want to finish my video game. I want to finish my video game so bad, and I'm going to make everything into a shader, because I'm going to make triangles and shaders. So shaders equals impossible. Yeah, so shaders equal impossible. Break the bottle. Hello, senor. Mix the melted ice water with the coffee prime. Ooh, dick in the box. Okay, that sounds insane. Can we solve AOC with shaders? That's actually insane. All right. So now it's time to try and challenge our understanding of the code. Can you tell where coordinate 0, 0 is in our canvas? Yes, at least with this picture, it should be pretty obvious. I assume 0, 0 is right here, which is kind of breaking my perception of what 0, 0 should be. Right? Because that should make everything 0, 0. So in the picture, that should be 0, 0. This should be 1, 1, because obviously red plus green equals yellow.
Hypertrain.
Hypertrain, 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 hypertrain. Hey, thank you very much. Defy us all. Appreciate that. Thank you, everybody, for the TTSs today. The TTSs have been off the rafters. Dick in a Box? I don't know the answer, Dick in a Box. But I do know the comedy by Opie and Anthony, if I'm not mistaken, which is Dick Insider, which obviously they had Dick Insider Box.
Costco. I love you.
You probably wouldn't understand. Thank you very much, Severe. Thank you for the 2 months, Twitch Prime. All right, what about 1001? Yep, that seems pretty obvious, right? So 10, obviously, this is very green. This is very red. All right. Okay, so that means red. Okay, so this is like X, this is Y. So I'm curious why this equals that. But I think if I were to do the same thing, I don't know if I would get the exact same answer, if that makes sense. Right? Right, so if I went to here and went 1 to negative 1, hold on. What does my screen even look like? So this is 1 to 0. So if I went like this and instead had 1 and had negative 1, right? Wait, no, those are 3 points in the same position. No, that's all wrong. All right, so here, let's go like this. Just to make things easy, I'm going to go here, and I'm going to draw I'm only going to draw 3. Just so I can make sure I understand this one. Okay, let's go like this. Let's go. Where is 1, 1? Okay, so 1, 1 is right there. That means if I want to do 1, 1, I'd go like this to make it half screen. I got it wrong. Okay. I got that wrong. That should partially fix it. Oh, baby girl.
Back on Twitch for the hyper train. Hip hip hype train.
Thank you. Oh, Cakes. Cakes with the raid. I didn't even see that. Cakes with the raid. Hey, Cakes, how you doing? If you don't know Cakes, kind of makes you a loser. Have you thought about that? Good morning. Thank you. It turns out I'm an idiot. I honestly thought I was the smart one, but it turns out I'm actually the dumb one. I'm the dumb one in this relationship. Okay.
Go Triangle Man. Triangle Man.
Okay, so there's 0, 0. I think 0, 0 is obvious where... Oh, look at it, still going. Oh, triangle. So there's 0, 0. That's obviously 0, 0. Thank you. If you don't know Cakes, better leave it that way. Yep. Are we writing GLSL and JavaScript? Well, technically it's WebGL, okay? Go, Triangle Man. We're trying RAM. We're ramming it in, okay? Which makes sense because that's 0, 0, 0 to 1. So this is the only thing that... This one obviously makes sense why this is this way. So if I were to go back here and I'd undo these two, you'll notice that the top corner should become green as I go right here, right? Is that not where green is? I thought green would be right there. I'm a little bit confused as to where... Okay, maybe I don't know where it's at. Okay, so that's what I would expect to be over here. Oh, it must be my math operations must suck. I must be having some bad math, bro. All right, so I should be able to go like this and just call this thing color, right? Okay, there you go. This is 0, 0, so that is 1, 1, and this is 1, 1. Okay. Can you upload your coding stuff to YouTube, like the tower defense? I didn't upload any of the tower defense stuff or any of that to the old YouTube, but I am going to be redoing things. So, Cakes, what I will be doing is that I'm going to be reviving one of my channels that I haven't been playing around with very much. So I go to YouTube / the Vimogen. And let's see, keep in mind the frag chord is totally different space from vertices, correct. And I'm almost there. I'm almost to 100,000 on this crazy channel. And so I'm going to just take that one, and I'm going to upload like today's video. I'm going to just upload just learning about shaders. Dude, why is everything so slow? I swear whatever I'm doing is causing my computer to suck. I'm just drawing this over and over again to the point where my computer is having emotional issues. Okay? I'm actually having emotional issues with my computer. There we go. Emotional issues off. I don't have, let's see, why not do this with CSS? Because I'm doing it with shaders. Have you thought about that? You need a tick rate? Well, I do. I have request next animation frame. Humor set to 0? Exactly. Where else would it be? You think I'm funny? You think I'm a clown? You think I'm like here for you? Clowning it up? Making laughs, making jokes, making hee-hees and ha-has? Oh, yes? Oh, okay. That's crazy. NDC coordinate ranges between -1 to 1. NCD is normalized device coordinates. Viewport ranges from 0 to 1, and screen ranges from 0 to width to height. There's also left and right-handed coordinate systems and row-column major matrices. Gotta love graphics programming. Again, clown confirmed. No, I'm not a clown. Okay? I'm not a clown. Look at my Twitter. My Twitter makes very serious tweets. Okay? Very serious, sophisticated tweets. Is it lagging because your PC, oh gosh. Because your PC is drawing while not in focus? Yeah, it's just drawing like wild. Thank you for the level 4 hype train. Oh my goodness. The Star Helix. Star Helix. Hello, Star Helix. Can I tell you something, Star Helix? I secretly respect Karen. All right. One stall rule. Yeah, absolutely. Secret respect is happening right now. Okay, so we're looking good. We're looking hot. Let's keep on going with this book of shaders because I feel like I kind of ended the. Can you imagine an interesting way of changing this color pattern to U time and U mouse coordinates? Yeah, I did that. We did that. We actually did that. After doing these exercises, you might wonder what else you can do with your new shader powers. I can draw triangles. Dog, I could draw triangles, and let's be real, I could draw my entire game that I'm making. My entire game, which is just black rectangles and a black thing, I can draw it all. In fact, can I be real here for a second? I almost feel, nope, never mind, it's not easier. I actually have no clue what the hell I'm doing. So the one thing I don't know what to do is, see how I have these different GLs right here? So this is something that maybe you'll have to help me with. Color buffer bits, I don't even know what that means. Oh, color buffer bits. Okay, so this is the buffer bits. Cool. So something that I think I'm probably going to struggle with, which is how do I apply different shaders to different triangles? I'm hoping that this helps me do that, because obviously different platforms are going to need to do different triangles. You need to bind a different shader? Oh, I figured that would be it. A new program, just a whole new program. You need multiple draw calls? Yeah, I figured I'd have to do different draw calls. But we got to get there first, okay? I'm not there yet. Okay? We're not there yet. GL, do that shit. Yeah. No, less draw calls. No, we're going to do more. You can train a neural network with the shader. Yeah, that makes sense. That makes a lot of sense. As somebody who used to do MLPs, multi-layered perceptrons by hand, That makes a lot of sense because you take your position. Hold on, how would that happen? I guess my only thing is how do you put the weights? I guess the weights are all just 0 to 1. No, how does that work? How do weights work? You probably need to learn some GL. I don't know. All right, so let's just keep on going. Here we go. All right, running your shader. Now, as a part of the construction of this book and my art practice, I made an ecosystem of tools to create, display, share, and curate shaders. These tools work consistently across Linux, Mac OS, Windows, and Raspberry Pi, and browsers without the need of changing your code. Running your shaders. Oh, okay, nice. Okay, cool. Yeah, we've seen all this. I'm happy. I actually like what I'm doing because it helps me kind of. I mean, that looks super cool, by the way. Like, what was built right here is super, obviously, like, super duper awesome. But I don't want to do that. Right? That last step, by the way, is insane. That it turns into a gear. That last step is just factually insane. Factually insane last step right there. I actually can't even read chat because of how many messages. Prime, did you die yesterday after I left? No, I didn't. I'm at the boss. I'm at 2 bosses, almost level 11. I'm almost level 11. Math do be crazy, dude, I know. I feel like I almost understand this. Except for Smoothstep. Too many messages? Sorry, too many messages? Sorry, yeah, too many messages. Not from you. That's fine. Classic Smoothstep hand wavery. Yeah, I know. Whatever that means. He checking out fighting the boss because TJ wasn't there. It's true. Well, the reason why I do that is because TJ is going to just literally mansplain to me why I'm a loser if I died by myself, but I'm going to go in with him, and then I'll still die, but I'll at least die with him, which makes it way better. Okay? All of a sudden, that's not a problem. I love artistic shaders because you can just draw a right random math and hope it turns into something cool. Yeah. Can't wait for Teach's Dong Gong. Dude, we're going to Dong Gong so hard on those guys. Dude, Dong Gong to the moon. Dong Gong to the moon. All right. This is super cool. I actually think this is super, super cool. Super, super cool. I'm going to just skip all of this, though. Right? I kind of want to just, like, I want to keep on doing the thing I'm doing, right? All right, algorithmic drawing, shaping functions. In this chapter, could be named Mr. Miyagi's Fence Lesson. Previously, we mapped the normalized position of x and y to red and green channels. So essentially, we made a function that takes 2-dimensional vectors x and y and returns a 4-dimensional vector RGB and A. But before we go further transforming data between dimensions, we need to start simpler, much, much simpler. Dude, let me paint that fence. That means understanding how to make one-dimension functions. The more energy and time you spend learning and mastering this, the stronger your shader karate will be. Okay, I'm ready. I'm ready to do this. The following code structure is going to be our fence. Okay. In it, we visualize the normalized value of x-coordinate, st, in 2 ways. One with brightness, observed by the nice gradient from black to white, and the other by plotting a green line. Okay, yeah. In this case, x values is assigned directly to y. Don't focus too much on the plot function. We'll go through that in more detail in a moment. Okay, so we're going to get the resolution. Okay, plot. A line on y using a value between these. Okay, so Smoothstep, 0, 2, 0, the difference between these two. Okay. I don't think I get this, but that's fine. That's fine. I don't need to get this. I do not need to get this. But what I need to do is the following. I need to obviously do the following. Are you guys ready for this one? What's the let's see, GLSL file extension? What is it? You're doing great, Sonny. Thank you. There's no official spec. Okay, there's Vert for Vertex shader, Test for Tessellation Control shader, Tessie for Tessellation Evaluation shader, Geom for Geometry shader, Frag for Fragment shader. Okay, let's go, baby. Let's go like this one. Let's go. I don't know what to call it, so I'm just gonna call it Shafrag. Okay, Shafrag. And what comes back from this thing? Okay, we got this thing, and let's go like this. Let's get the text. Actually, can I just do this? I hate prefix. Prefix await is just the worst. Can I go like this? Okay, well, that did not highlight it. Okay, a little bit of coloring. That does make me feel a little bit better. Right? That does make me feel a little bit better. Go like this. Nice. My autism's kicking in. I want to hear that song again. You're not allowed to tell me what to do. The Lang is pretty low barrier. You'll smooth roll it. I feel pretty good about this whole experience, right? The autism's happening. All right. I like spaces, okay? I'm a spaceman. I'm a spaceman because this is unreadable for me because it's hard for me to know what's happening when there's so many symbols and numbers all close. The tism is real. I got some severe tisming going on right now. All right. For real, dude. For real. Tism the tasm here. Okay. All right, so I don't really understand this. Obviously, Smoothstep is confusing. This must...
Welcome to Costco. I love you.
I don't know what that means. All right. So we're going to take a color. Let's see, float Y. Whoa, that's a crazy thing that we take the X and we call it a Y. This is actually insane behavior. All right, so anyways, frag equals this one. Okay, we got 3 Ys. We're going to plot the ST. Then we're going to do 1 minus this to get the values, I guess. Multiply by the color. Plus the percent. I don't know what it is. Shit you got to do when shadowing is not an option. Yeah, but we could have just called it X. I'm just saying, one could have called it X and it would have been just fine. Just play with line 17 and you'll see. Oh yeah, true. I know. All right.
It turns all your bad feelings into good feelings.
All right, so now that we have this, let's go like this. Hey, thank you very much, Star Helix. Let's go star helix here. And I'm also going to go like this. I'm going to jump in here, and I'm going to drop that. Set timeout. Let's go star helix, and it's limbo. Appreciate that. Hell yeah, brother, man, baby, child. Let's go render. And I'm going to just render every like 200 milliseconds, not to explode my CPU or my GPU. All right, fragment shader is not defined. Absolutely. Okay. I got a very different answer than he did. I got a very different answer than he did just by copy and pastaing. My copy, pasta, not the same as his copy, pasta. Man, this is a trivial shader with only one pass that ain't gonna explode your GPU. Yeah, but if I call this like maybe 1,000 times a second, it will actually, it bogs my CPU down. You need to draw two triangles in the shape of a quad to take up the whole screen. That's a good point. Good answer. Good answer. Good answer. Everybody give him a good answer. Good answer. That's a good answer right there. So I need a bottom left. Good answer. Hey, good answer. He did warn me about this white screen. We have been specifically warned about this white screen. Fax no printer. Yeah. All right. All right, the following code is going to be our fence. In it, we visualize the normalized value of the x-coordinate ST in two ways. One with brightness observed by the nice gradient from black to white, and the other with plotting a green line, on top. In this case, the x value is assigned directly to y. Don't focus. The x value is assigned directly to y. Don't focus too much on the plot function. We'll go through that in more detail. Okay. My guess is you know what? I never passed in resolution, right? No, I definitely pass in res. Okay, so we do pass in the res. Okay, so that doesn't seem to be the issue. That does not seem to be the issue, right? We're passing the res. Oh, you named it URes? Oh, ship. Okay, wow. Instantaneously fixed. Instantaneously fixed. Dude, this green line, I don't even know where that green line came from. That green line is crazy. It obviously, it must come from this, but I don't know how. Right? Like, why isn't there like lots of green over here or here? How come there's just a huge amount of green right here and then like none here? No idea. Okay. Is listening to the same song a sign of tism? Oh yeah, that's a strong tism. That's a strong tism sign. All right, quick note. The Vec3 type constructor understands that you want to assign the three color channels with the same value. Yep. While the Vec4 understands that you want to assign, you want to construct it for four-dimensional vector with three dimensionals plus 1/4 value. In this case, a value that controls the alpha or opacity. For examples, lines, see for example, lines 19 through 25. Okay. That's this whole business right here, right? Yeah, I got that. This code is your fence. It's important to observe and understand it. Okay, I don't. So let's understand it. And you'll come back over and over to this space, 0 to 1. You will master the art of blending and shaping this line. I want to. This 1-to-1 relationship between x and y, or the brightness, is known as linear interpolation. Interpolate me, daddy. From here on, we can use mathematical functions to shape the line. For example, we can raise x to the power 5 and make it a curvy line. Yes, that's true, but I still don't understand how or why. Okay, what I don't understand is how or why this works. I don't understand how that line is drawn to begin with. Okay. Okay, hold on. So this color is where it's happening, right? So this color, let's see. Yes, if percent is close to 1, it adds green. Correct. But the thing I don't understand is that when percent is, say, 0.5, how come it doesn't add 0.5 green? Right? Because in my head, at, say, 0.5, this would be 0.5. It does. Okay, well, shit, then I don't get that at all. Okay, you guys are all saying words I don't seem to understand. So what I'm going to do is I'm going to go like this. I'm going to ask Jippity. I'm going to ask Jippity a little Q or two about this. All right. Here is some GLSL. Now, this draws the screen going from black to white, from left to right. But there is a green line down the center. How does the green line appear? I don't like. How does the green line? See, how is there a green line and the rest of the screen isn't filled with some percent of green? Right? That's what I don't understand. That's what I'm struggling with. In GLSL code you provided, the green line is produced by the plot function, which modifies the color value only in a narrow range around the line. Let's break it down step by step to understand why the rest of the screen is not filled with green. Yes, that's what I want to understand. Fragment coordinates are normalized by resolution. Yep. Okay, that makes sense. ST is a normalized fragment coordinate where S and T are ranges from 0 to 1 across the height and width of the screen. Yes, that's okay. So I get that part. I get that this is 0, 0. This is 0, 1, 1, 0, 1, 1. I get that part. All right. Let's hold on. Let's just get let me read this for a second. Quit giving me suggestions here. Just hold on. Defining the line position. Let's see, this defines a diagonal line where the y value is equal to the x. A line from 0, 0 to 1, 1 is normalized coordinates. Okay, well, I mean, I understand that it takes... Okay. Plotting the line. Plot calculates the proximity of the current fragments STY to the y value, x specifically. Okay, I don't really know. Okay, so I get this. This is obviously how close is y to x, right? Gives the vertical distance from the line. Yep, okay. Smoothstep 2 creates a smooth transition around the distances where fragments close to the line within range of 0.2 have a percentage close to 1. Fragments that are far away have a... Okay, so that's my question. Okay, so this is... Okay, so Smoothstep must mean if it's within this 0.02. Okay, so hold on. Let's go like this. Does this double the line? Does that double the line? Does this become a tenth of the screen? Okay, and this is half the screen. Okay, someone said remove the absolute value. Okay, let me understand that. Interesting. So this is everything within 0.2, but the negative, everything that's below 0.2 gets smooth stepped. Okay, so I think at least, okay, I'm starting to get it. I'm starting to get this. Okay, so anything that's within the range of 0.2 goes from 0 to 1. So that makes sense. Okay, so that's why it starts off kind of like shady and then goes all the way up to green and then back down to shady. It's because effectively between the distances of 0, 0 to 0.02, it goes from 0 up to 1, right? So that's why it's such a fast ramp. In other words, it's going to go from 0.
Welcome to Costco.
If this is 0 and this is 0.02, and this is obviously 0 and this is 1, it's going to, I assume it does some sort of linear thingy, right? If that's fair. So that means as y, if I'm correct on this one, as y approaches x, it goes like this. It sits at 0 and then goes swing, right? It just like zips up really fast. It's like 0, 0, 0, 0, 0, 0, and just goes really quick. It's called smooth. It's not linear. Okay, so it's not linear. It doesn't, okay, it's smooth. Whatever that means. So it's going to look something like, instead of that, it's going to look something like, I assume like that. There's a multi-step smooth function. The default one isn't that one. That's what I assume. Hey, VS Baggins, appreciate that. So I assume this is what's happening. This is cool. This is a cool diagram. Let's see.
Welcome to
The
Costco.
min and the max. So this must be
I love
0 and this is 0.02, right? This is 0 and this is 0.02. Am I correct on that? So it's more like a trigonometric function, or so it's going to look something like that. Is that fair? Sigmoidal. Yeah. It looks like the inverse tangent, right? Because isn't that like an inverse tangent right there? Isn't that effectively the inverse tangent from -1 to 1? I might be correct on that one. I might be incorrect on that one, but effectively what's happening. Sigmoid. Prime has never looked more confused on stream. Oh yeah. No, I know. We're doing something that's way outside of my comfort zone. It's not sigmoidal. It is the sigmoid function. Okay. We mathing. It's a typical S curve for smoothing. Okay, S stands for smooth. Okay, cool. Okay, so I'm getting more of this. So now let's understand this part. Okay. So we then take X and we put it in a color vector of all three. So that means we have a uniform. So as X goes from 0 to 1, it goes from black to white, correct? That's why it's black on this side, white on this side. It doesn't go black to white from corner to corner. It goes from black from white from X to Y. Because it just slowly, as it goes over and grows, the whole thing gets it.
I love you.
Okay. Okay, technically not uniform. Yes. Gradient. Thank you, Lithium, for that. To resubscribe tier 1 for 53 crazy months, Lithium. Lith, baby. Baby Lith, appreciate that. And Cashew Croissant, appreciate that. Let's go. Okay. He has a gamer wrist red mark. This right here? Yeah. I got it, baby. But mine's from coding. Okay. And using a mouse. I'm not used to using a mouse here. All right, so we have this thing. And then we get that percent, which is mostly going to be a bunch of zeros, right? So if I've done this correctly, it's almost always a bunch of zeros. Oh, I get this. Okay, so it's like this is 0. 98% of the time it's 0. That means this is 1 98% of the time, which is just the color. This is 0 98% of the time, which is going to be zeroing this whole thing out. That means that this will be mostly 0, except when y is very, very close to x. And when that happens, then we're pegging green. Now, what I don't understand. Oh no, no, never mind. I do understand it. Because this becomes 0 then, which means we're actually going from our black to white scale and actually only going into a green scale. And that's why the green is so vibrant, and it's not like slowly transferring, say, to yellow or to white. It's not going from green to white. It's staying green all the way through because this gets dropped to 0 as we do it. Okay. I get it. I get the thing. Right? I actually get the thing. Yeah, if I comment this part out, that should produce, without the green line. Okay. Hey, that's hard to get. I know a lot of you guys are like, dude, this is so easy. For me, this is very, very hard, okay? This is the first time I've ever done this. Can we all agree that this is just not easy? The subtle joy of you realizing your face is amazing. Yeah. You could have also done this with the gradient line. Now, I'm sure there's a way to be able to do this easier. You could swap the 0.2 and 0 and everything else is green except for the line. Yeah, I guess I don't know what those first 2 arguments of Smoothstep are.
Welcome to Costco. I love you.
Okay, so that means everything on the outside of that. Okay, I need the Smoothstep function explained. The first 2 are, can you explain the first 2 arguments of Smoothstep? All right. I know, I can look at the docs, but Jippy's great at explaining things. I like using Jippy for explanations, okay? Dean Wentz, thank you for the tier 1. I appreciate that. And Dipshit Dev, let's go, baby. Oh my God, it's been 3 whole months. Time flies. Well, I appreciate that. It's not been 3 whole months. It's been 11 whole months, dog. I think Jippy usually does a really good job explaining that. All right. Define the range over which the smooth transition occurs. Here's a detailed explanation. Float edge 1, float edge 2, X. Okay. The lower edge of the transition range, the upper edge of the transition range. The input value for which the smooth transition is calculated. Okay. So that means that this is, in our little version, this is off. This is effectively on. We're using this as off and on. And so the lower edge of the range is 0.2. The upper end of the range is 0, which must invert it. So Smoothstep must have the ability to realize that when the lower range is higher than the higher range, it's like an inverted match. If I understand that correct. And so it understands that everything effectively above 0.02 is on the offside. Everything below 0 or 2.0 and below it is on the on side. And that is, where's that thing? Where's the thing we were just looking at? So that must make sense, right? Because this is the offside. Everything below the min is off. Everything above the max is on. And since they're flipped, it makes this the min, which means that this whole thing's flipped, which means that it has to be an inverted version of this. Okay, yeah. Okay. Yes. Smooth walk is a rich guy's a walk all like this poor guy's walk like this. Wait, what? So when you flip them, it inverts it. Yeah, okay. Bro just created a gradient. Yeah, I know. It's hard, man. I just saw you have Shader Toy open. That's what's killing your PC. My PC works really, really nice right now, right? Everything is fine. Just so you know, okay, we've had this conversation like 18 times. So let's have this conversation one more time. Okay, so let's just have it one more time so we can all shut the hell up about it and never speak of this again, okay? So now I'm going to go like this, and now I'm going to go back here, and you'll notice that it just starts getting a little bit more chunky. Oh, yeah. Did you see that? It's just like it's feeling chunky. Oh, we're feeling a little chunky. When I go here, oh, yeah. Oh, yeah. Oh, yeah. Twitter. It just feels chunky. Okay. Then I'm going to go like this. Go here. Do that. Go here. Go Twitch. Oopsies, not Twitch. Twitter. And it still feels chunky, but it feels less chunky. Clip it. You got to kill switch it. Yeah, my cat is chunky. I don't really have a GPU. You only have one GPU for all of this. Yeah, I only have one GPU. And this thing, when I do, I don't have VSync on. So that just means I believe this means render infinitively. Render as fast as you humanly can render. I don't know. I don't know, though. To be fair, I'm also stupid. All right, I'm going pee again. I drank a lot of water. And a lot of coffee. Be right back. Thank you, Dish Pit Dev. Appreciate that. All right, let's keep on going. That's a cool picture, by the way. All right, let's keep on going. So I feel like I get this. Interesting, right? Let's see. On line 22, try different exponents. Line 22, try different exponents. Oh, wait, we're powing it. Oh, we give it the pow. Okay, let's pow it. Yeah, we can pow it. So I go pow, and that would be 5x. See, then there's this. Now I don't understand this. Okay, so now I'm back to sucking it. I'm back to just absolutely confused again. Okay, so he did all right, is that what? Oh, yep. This is much more confusing. Okay. Did you skip an example? I did not skip an example. Goes from this to this. Okay. All right, so let's try to understand this one. All right, so y is x to the power of 5. So y is just like a giant number. Correct? Y is a absolutely giant number. No. Y is not a giant number. Y is a very small number. Y is like really, really tiny. It's really, 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 really tiny. Yeah. Because it goes between 0 to 1, so this would be a really tiny number. It's like it just stays small and then shoots up at the end. Okay. And then we do all the same stuff, so this all remains the same. I really don't like that it's called percent right here, but whatever. Okay, so percent right here. So it's going to mostly be 0. So it's going to mostly be from 0 to this. And then right at as it starts growing, then it's going to kind of shoot up towards 1, towards the end. Then we kind of invert it. So that, I guess, this part is confusing to me. What is this part? Why is that there? Oh, that's... Oh, I got to edge both. Oh, we're edging. Okay, hold on. That's right. Okay, so that's because before... Okay, hold on. The reason why this works out is before we were using an absolute value. But instead, we're kind of hand-rolling our own absolute value. And that is because percentage that's being passed in probably looks something like this, right? I'm not exactly sure. It looks something like that, right? Because it's a 5x exponential, right? And so for the most part, it's going to be a lot of zeros minus 0.02, right? Is that what it is? Yeah. So with that, it's going to be a lot of 0.02 to 0. So it's going to be a lot of 0.02 all the way to 0. So this will be its clamping range. And then the other side is going to be from 0 to 0.2 or 0.2, right? Like that's going to be a lot. That's going to be a large portion of it because it's going to be a lot of zeros. But then it starts to get kind of wild there for a moment in this. So I'm trying to understand this part. So I get these two, right? So I kind of get this one. It's just that how does this exactly work? Then what happens? As this thing grows really fast, as it grows really, really fast, as it goes up to 1, effectively at 1, it's going to be 0.98 to 1, and it's going to be from 1 to 1.02. Okay, which is going to leave a little bit on this side and a little bit on this side, right? I think that's why when we look at it right here, it kind of is actually off the screen starting right here because that last 0.2 is actually right over here. Yes, Grims, I can see what you're saying, buddy. Okay. Perform Hermite interpolation between two values. Description: Smoothstep performs a Hermite interpolation between 0 to 1 edge of this. This is useful case when threshold functions and smooth transition is desired. Okay. Okay, this in fact actually helped me significantly less. I'm a Hermite. I'm not really sure what that is. I'm going to have to go learn about, we're gooning this stream? Well, we gooning. So I'm going to have to go learn what a Hermite is. By the way, that actually was somehow less useful, but I got to look at the implementation. So where's the implementation of this? You sent me just the docs. I don't know where the implementation is on the docs because I just don't even know. Keep reading the book. You'll get how, I think I'm getting Smoothstep. Well, I get Smoothstep because someone sent me this. So it's off on both sides. Yeah, because this one goes from off to on, and this one goes the other way. Am I getting that correct? Thank you. R. Cornston. It's the description of the implementation for the function. Yeah. Yeah, 0.2 is the proportional thickness, correct. Because if I were to go with 0.7, that's the percent of the screen in which this thing is taking up. And it gets a little bit smaller because this whole area is getting tighter, right? Since this is not linear, right? I assume that this is about 7% of the screen if it was right here. But this is the center, because remember the plus 0.02 is actually on the bottom. So it's off the screen down here. This is just the first part. I think I kind of get this. I think I kind of get this. I think I do. All right. POW is a native function in GLSL. There are many others. Most of them are accelerated at the level of hardware, which means that if they're used in the right way with discretion, they will make your code faster. Replace your power function on line 22 and try other ones like exponential, log, squirt. Some of these functions are more interesting when you play with them using pi. You can see on line 8, I have defined a macro that will replace any use of pi with this value. I wonder if this works in this language that we're using. I wonder if I get an error with this. No, okay, so I can do that. Okay, so log. Oh, this thing needs a something different? What does it need? Oh, that's because okay, I think I understand why STX didn't do anything here. And that's because for the most part, that's just 0, right? Actually, I don't even know what the answer is. It's or it's 1. I'm not sure. Okay, what is the what is log of 0.01? I don't know what the log of that is. -2. Oh. Is approximately -1. Okay. So it's gonna be just a value between some large negative number and 0. Okay. Okay. Yeah. Okay, I get it. I get that. Log is just the power of 10. Okay, it's a power 10, not power 2. Okay, yes. Yes, it's a power of 10. Yes, you're right. It's base 10. It's very base. Okay, so that means pretty much this is just some super large negative number. This is a super ultra large negative number, which shouldn't do anything, right? There's part of the log function hanging out over there. Right, so if we took this guy. Oh, what's this? Okay, let's actually keep going. Okay, what's this thing? GLSL has some unique native interpolation functions that are hardware accelerated. This step interpolation receives 2 parameters. The first one is the limit or threshold, while the second one is the value we want to check or pass. Any value under the limit will return 0, while everything above the limit will return 1. Oh, that's kind of fun. Okay, so we could do Smoothstep, and we could do step. Oh, hey. Oh, hey, yeah. So if we did step, that makes sense because that makes sense. That makes sense. Except for I think I have mine backwards. Why is mine backwards? How is mine backwards to what is being displayed right here? Like, I agree. Everything should be the same. Order of arguments. Oh. You're right. Oh, yes. Okay. Oh, yes, because that... Okay, yeah. Oh, that makes sense. Okay, so that is the thing that's... Anything below is 0. Anything above is 1. There we go. Okay, I get that. Okay. Another unique function is known as Smoothstep. Given a range of 2 numbers, a value of this function will interpolate the value between the defined range. The 2 first parameters are for the beginning and end transition, while the third value is for the interpolation. Okay, so we can actually Smoothstep from 0 to 9. Oh, yeah, I see how this works. Okay, so that means we can Smoothstep. That's right. So we can Smoothstep from 0.1 to 0.9, and this will be off when it's below 1 and on when it's above 9. Or in other words, 0, then Smoothstep between 0 to 9, and then 1. Crazy. Can you believe what we can do? Can you believe what is done with 2 triangles? That blows my mind. This graph was made with 2 triangles. Okay, so I feel like I'm starting to get this. This is because this right here, this is the Y part. Okay, so this one is just going to make a line for us. Effectively, we're going to just we're going to pony step our way through all of this real easy. And since our since y is going between 0 and 1, we're kind of, okay. The middle line, or the bright green part, is actually where the real line is. You just can't really see it. Okay. In the previous example on line 12, you'll notice that we've been using Smoothstep to draw a green plot line. Yes, I get that now. For each position along the x-axis, this function makes a bump at a particular value of y. How? By connecting two smooth steps together. Take a look at the following function and replace it for the line 20 above, and think of it as a vertical cut. The background does look like the line, right? Uh-oh. Okay, hold on. How? Okay, hold on. In the previous example, line 12, notice that we're using Smoothstep to draw the green line. Yes. For each position along the x-axis, this function makes a bump at a particular value of y. How? By connecting two smooths together. We take a look at the following function. Replace it for line 20. Line 20 is this one. Okay. So we're going to actually go from 0.5 to 0.8. I think I understand what's going to happen here. What this is going to do is, this will be from off to on and from on to off, which I assume is going to make a very large amount, a very big one. No. Oh, that makes sense. Okay, yes. Dang it. Okay, yes. Because this is the percentage of the screen that's going to be captured. This is going to be mostly 0 up to 1, and from 1 back down to 0. Yes. And the reason why is that this goes 0 to 1, and so this is going to be off. These will both start at 0. Yes, they both start at 0. Then at 0.2, this one starts going towards 1, but this one remains at 0. Then at 0.5, this one remains 1 for the rest of the time. And this one slowly goes to 1, which brings it back down to 0. Right? So that's why it starts at 0 to 0.2, goes all the way up to 0.5 as 1, then the second function kicks in and sends it all the way back down to 0. Let's go. That's crazy. Oh, that is insane. Triangles are goated, man. Triangles are crazy. Mike showing me the keystrokes in Vim. Yeah. Dude, my mind is blown. Triangles, how do they work? Mind equals blown. There we go. All right, when you want to use some math to animate, shape, or blend values, there is nothing better than your best friend sine and cosine. Yep. These two basic trigonometric functions work together to construct circles. They are as handy as MacGyver's Swiss Army knife. It's important to know how they behave and in what ways they can be combined. In a nutshell, given an angle in radians, they will return the correct position of x cosine and y sine of a point on the edge of a circle, with the radius equal to 1. But the fact that they return normalized values between -1 to 1 is such a smooth way to make them an incredible tool. Yep. Yeah. Okay. I feel like I get this. I get this inherently, I feel like. Right? I feel like I get this. Yes. It's time to take trig again. Luckily, I still remember a lot about... I remember this well enough that this should just work for me. I shouldn't have any problem. Frost Prime, let's go, baby. I get nothing. How you doing, bud? You doing well? Okay, so I'm getting this. Trigonometry 101, yeah. Let's see. While it is difficult to describe the relationship between trigonometric functions and circles, the above animation is a beautiful job. Yes, this makes sense. This also makes sense. This has to be sine. I can tell this is sine. Yeah, this is sine. Let's go. Because sine starts at 0, cosine starts at 1. That's why it works for a circle, is because 1's right here, 0's right here, and then as you animate it, the cosine goes back down to 0, which brings it this way. So the x goes to 0, and then sine goes up to 1 as you get to, what's it called? What is that? That's half pi? Sine gets, yeah, because at half pi, it gets to 1, correct? Yeah. Okay, unit circle. Okay, I feel good. I feel fresh. Take a careful look at the sine wave. Note how the y values flow smoothly between +1 to -1. As we saw in the time example, the previous chapter, you can use the rhythmic behavior of sine to animate properties. If you are also, let's see, if you are reading this example in a browser, you'll see that you can change the code in the formula to watch how the wave changes. Don't forget the semicolon at the end of the lines. Oh yeah. Okay. So then I assume cos. Yeah, there you go. 1. Okay, perfect. I knew this. I know these things. Let's see. Try the following exercises and notice what happens. Add time, u time, to x before computing sine. And let's see, internalize that motion along the x line. Okay. U time. So hold on. So does that mean I can take this son of a bitch Wait. Hold on. How do we do that? Can we go like this? Float time equals sine u time absolute value. Are we getting unhinged here? Are we getting unhinged? Are we hinging? I think we're unhinging. Let's find out. This may be insane. Let's find out. We're improvising. We're improvising, okay, people? We don't know what's happening here. No semicolon. We'll get it. We'll get it. We'll get that semicolon. Don't you worry. Let's go like this. Let's go back down a little bit here. I think I had it right in here. Do I not have it? Yeah, I mean, I do have these guys. Yeah, I don't even know why I just got lazy. I got lazy. I could just do this without having to worry about this. Okay, const start equals date dot now. Let's see, duration. Const duration equals date dot now minus start. And then we're gonna want to take this and we're gonna want to divide it by
I love you.
1,000, and then we're gonna want to multiply that. I like to use parentheses, okay? Times by math.pi. There we go, right? Let's go half pi. Let's halvesy pi this. So every second, a half of a pi goes by. All right, hey, thank you. The old dicky twist, dude. Get that dick twist in, baby. And so with that, I want to take this thing, and we want to go. We'll go u time. Set that. CT that. Go back here. X that. Go here. Go duration. Go there. Get those two things. Let's go. And go u time. Jump back here. U time. Take that one. And we got ourselves a problem. Got a little bit of the, forgot the old semicolon, as you guys warned me. Okay. Oh, okay. Okay, first off, let's calm you down. Let's calm you down a little bit. Let's bring it down. Bouncing to the left, let's go. Okay. Why does it bounce to the left? Think for a second. Why does it bounce to the left? Why did it bounce to the left? That's because this thing is going between 0 and 1, which means I'm only increasing to one side. Correct. I'm only increasing on one side. So this absolute value made it only bounce to the left. So when I do this, yes. Okay, so now that we have that, that also means we don't want to do the whole thing. We don't want to go between -1 and 1 because that puts us completely off the entire screen. So let's do half the screen. And by doing half the screen, we should bounce at the corner. We should come back to the other side. We should bounce at the corner, come back to the other side. Okay. Nice. Is screen tearing your i3 thing? It's my i3 thing. Yeah. You should be jealous of that. Uncapped frame rate is kind of funny. I think I'm capping that frame. Oh no, I'm uncapping that frame rate here. Set timeout. There we go. Have some nice chunks. Pap. There we go. So we're chunking, and I still get vertical tearing. Look at that. You still see some tearing in here. Dude, I just haven't fixed it, okay? This is Linux, okay? Shut your French fries, okay? Smooth. Chunky. All right, there's a song here that I might, again, I feel like I get that song autism really hard today. Switch to Waylon, you old ass. I will. I don't have a problem switching to Waylon. It's just I'm an ass. Dude, damn, UE5 looks nice. Yeah, hell yeah, brother, man. Move your ass to Waylon already. I know. I'm doing the smooth criminal. The police are coming. Okay, so this is actually pretty cool. So I just did that. We did that. We understood it. Which means if I go like this instead of using that, I'm gonna go like this. Float U mouse X. Float U mouse that, right? Let's just, okay, just hold on. Hear me out. Hear me out on this one. Hey, por qué, Maria? Just hear me out on this one, okay? So if I did those two, I should be able to go here. We're gonna drop this time. We do not need the time. What we're gonna do is we're gonna actually start from okay, yeah, autism kicking in. Okay. Okay. Let's go like this. U. Percent. I don't know that. Oh crap! I already used that one. Mouse percent equals percent equals let's see, U mouse X divided by U mouse U res X. Let's go. Okay, put in one of those bad boys. So that must mean I should be able to take this and go right here, and I should be able to go plus mouse percent. Take that one over here.
Welcome to Costco. I love you.
Do I not have U res? Do I not have U res? I don't have U res. Time, undeclared identifier. Time, yeah, we don't have time. Just out of time. Okay, so I think I did that all. All right. Okay, I'm off by half. We're off by half. That's okay. That's okay. That's okay, because we don't want to do that. In fact, what we want to do is actually go like this. We actually want to go like this, minus 0.3 to mouse point, and we want to go from mouse point to mouse point plus 0.3. Yeah, look at that. Look at that bad boy go. Oh, baby. Bremo, Bremo, Bremo. Look at that go. Let's go. Okay, so that makes sense. Beautiful. Look at that guy. Look at these two triangles. Oh, okay. Yeah, silly. I know. Sorry, Vitis. I'm still getting there. Not good yet. Not good what? This is beautiful. Look at that. I only got 2 triangles. That's like 2. Just use the Bofides method. Really, the Bofides. What's Bofides? Oh, dang, they're nuts. Why did I ask to put Bofides method in my mouth? That's crazy. Why would I do that? Why would I do that? Low-key, we're undermining the entire AAA. Oh my gosh, he fell for it. Dude, I'm actually impressed. I'm personally feeling really good. All right, so I feel like I feel like I did everything I wanted here. Let's see, add a higher integer seal and smaller integer floor as a resultant of the sign. Oh, that's kind of fun. Yeah, you could do that. Okay. We don't need to worry about it. Okay, some extra useful functions. At the end of the last exercise, we introduced some new functions. Now it's time to experiment with each one by by uncommenting the lines below one at a time to get to know these functions and study how they behave. I know you are wondering why. A quick Google search on generative art will tell you. Ooh, unfortunately, this book's going to want a slight update on the word generative art because that now has been co-opted in the last 4 years. Keep in mind that these functions, generative art aware, yeah, that name probably doesn't quite come up with the same thing. Let's find out. Generative art. Used with autonomous systems. Ooh, practical. Okay, maybe it is. Maybe generative art is correctly being identified. Nice. Okay, I think they're right. Nope, not bad still. Okay, that's good. That was actually, you know what? That's much better than I thought it was going to be. Honestly, I thought it was going to be all LLM stuff. Like, that's so cool, whatever that is. That's crazy. It looks like fabric. Yeah, I now identify as generative art. Yeah, generative art is not AI generated art. Yeah, but the word generative is a tricky one, you know? So basically math functions as art. Yeah, keep in mind that these functions are our fence. We are mastering the movement in 1 dimension, up and down. Soon it'll be time to do 2 dimensions, 3 dimensions, 4 dimensions. Oh my gosh. Am I about to get hit with the draw the fucking owl? Oh, okay, it didn't. I thought as I was gonna go down, it was gonna poop out this. I thought for a second I was gonna be like, dude, how did that turn into that? That's crazy, dude. I thought I was gonna get the full on 100% draw the fucking owl. Oh my gosh. Owl moment, yeah, it wasn't. That would have been so a pox line, I know. It's on the next chapter you do that. Oh my gosh. Okay. Let's see, returns only the fraction part of the number. Oh, interesting. Okay. I mean, I get this, right? So return x module 0.5. Yep. Okay. Fraction of that. Okay. I feel like I get this. Advancing shape functions. Golan Levin has a great documentation of some more complex shaping functions that are extraordinarily helpful. Porting them to GLSL is a really smart move to start building your own resources of simple code snippets. Polynomial shaping functions, exponential shaping functions, circular and elliptical shaping functions, Bezier, and other parametric shaping functions. That's pretty cool. That's pretty cool. This is pretty cool stuff. Like chefs that collect spices and exotic ingredients, digital artists and creative coders have a particular love of working on their own shaping functions. Okay. Okay. Let's see. How do you say his name? Inigo Montoya? My name? All right, let's see. It has a great collection of useful functions. After reading this article, take a look at the following translations. Okay, I will. Pay attention to the small changes required, like putting the dot on the floating point numbers and using GLSL name for the C functions. For instead of POW-F, use POW. Okay. Okay. Inigo Quilas. Keep your motivation up. Here's an elegant example made by Danguafer of mastering shaping functions. I can't tell if I'm lying to myself or if it's getting brighter. Is that changing or was my eyeballs deceiving me? It's paused. Play. That has to be such crazy shader code. Right? Just thinking of it in my head, this just has to be, because this is a bunch of sine waves, right? Just a ton of different sine waves with these different points. I don't really understand how it makes something so bright, though. Which is crazy. Yeah. He said, here's an elegant example of mastering shaping functions, karate, which just makes me go, I'm a dum-dum. Exercise. Take a look at the following table of equations made by Kind and see how combining these functions and their properties to control values between 0 to 1. Now it's time for you to practice replicating these functions. Remember, the more you practice, the better your karate will be. Yeah, that makes sense. Okay. Interesting. Yeah. I guess this is where I'd go through Graph Toy 101. Okay, nice. That's pretty cool. So I guess this is where I'd have to try to go through and see, can I replicate a lot of these? I don't even know. Now it's getting exciting. Dog, we've been here for 4 hours. Gosh, you know what? What kind of crap is this? If I can't study something for 3 hours a year, familiar with most of these from easing functions. Yes, I know. I have been reading for 4 hours. I expect to be an expert. Why am I not the best at this already? All right, I feel like for to draw 2 triangles. Look at this triangle. Look at those triangles. Look at that triangle. Okay, look at it. Can't you see the triangular nature of it all? Okay, here's the deal. What's your triangles per hour? So many. 4 hour expert pog slide. Yeah. All right. So here's my plan. I'm going to go heat up some water and get ready to do a little bit of pour over coffee time. You guys want to do some coffee time? Are you an expert yet? Ginger Bill, I'm shockingly not an expert. I spent so much time doing math 12 years ago, and I'm not immediately great at this. It like pisses me off. I actually have to like learn again. Damn, what an annoyance. Dude, Ginger just sucks. Absolute shambles. Can you paste? Yeah. POE break? Take a POE break, dude. I love that dude, it's going to be nothing. Let's hear. Are you excited for the data structures? The part that come next, so damn, data structures? Bruh, SDF is Alamo, dude. I don't know what that. I don't even know what SDF is, but it's I'm feeling very owl mode right now. What this feels like is this is something that I'd had to practice a whole bunch to get anywhere near, right? Go ahead. You're hurting yourself. You know the functions from eases. Yeah, I know some of these functions from eases. Like I can tell some of them right away. I can also tell some of these, like this one, this just feels, I mean, this feels like a sine. This one is some sort of parabola. Now we're getting into some sort of power of 3 function here. Some sort of S curve going on. I feel like I can kind of see some of these just right away. Right, I think it actually tells you them. If I zoom in, I think it actually even tells you what they are. 1 pow, absolute value of 0.5. That's kind of crazy that it goes up to a point. The new Slim Shader Shady, yeah. This is a specialized field in game dev too. People, let's see, people only do this. You can see why. Yeah. Sine does not make a circle most of the time. Well, you need a lot of stuff. Oh, cosine. Yeah, the cosine makes sense because sine's at 0, it's a 1, right? So that's cosine. Yeah. I'm less stupid. I mean, if you really think about it, sine and cosine, they're just the same thing, okay? They're the same thing. All right. Now comes the hard part. I feel like to really get the next thing down, I gotta figure out how to... Hey, I guess I'm back? Did I disconnect? Can I get some Fs in chat? Nope, chat's frozen. Frozen chat. I actually can't even tell if I'm live or not. Am I live? Am I live or am I back? Am I back? I hate getting disconnected. I hate getting disconnected. That's just makes me angry. Still live? Yeah, it makes me angry. I hate getting disconnected. Hey, here's the deal, people. I gotta go write some crap. So I'm gonna go write some crap. Sorry, I gotta go. This was fun. Now I want to do one more day of shaders, because now I feel like I have the ability. I think I can draw this. I don't understand how to draw sparkles without drawing more triangles, which I think that's what you do, right? These would each be like little triangles right here. Little triangles, oh, little triangles, little triangles.